So hello everyone, welcome back to a new video. In this video we will be discussing the complete data structures. Yes, we will be discussing complete data structures and algorithms for TCS NQT. So this will be a one shot video where we will be discussing every concept, every data structure. We will be solving story based questions. We will be solving story based questions. Then we will be solving some data structures questions, some math related questions, few permutations. Everything will be covered. So this is the agenda for today's class. Everything. So what is data structures? How many data structures that we will be learning in this video is, firstly we will be learning the linear ones, then we will move forward to the non-linear ones. Done. In the linear ones we will have arrays, we'll have strings, we'll have array strings, then we'll have linked list, then we'll have stacks, queues. These are few linear data structures that we will be solving. Then coming to non-linear, we'll be having trees, graphs, that's all. And we'll also be learning algorithms such as first one would be prefix sum. Then we'll learn sliding window algorithms. Then greedy algorithm we'll be learning. Then searching algorithms. In this we'll be having two linear and binary search. Then we'll be learning sorting. We'll be having basic sort and advanced sort. In basic we'll be having bubble and insertion. Then we will be having selection. In advanced we'll be having merge sort, quick sort, heap sort, few things. And what else? That's all. These are few of the things. And here we'll be learning also recursion / dynamic programming also. This dynamic programming comes into algorithms part, but recursion and dynamic programming questions also we'll be doing in this video. This is the agenda for today's video. So before that we need to understand we are solving the programming language that we will be taking in this would be C++. Okay, we'll be taking C++ as our coding language. Coding language would be C++. So why C++ and what are we doing? See, if you are just for problem solving, you can definitely be in this lecture, because many people I see in the previous lectures also which I have given, people say that vote for Java, Python. Few people will say Python. See, if you know Java and Python, understanding the approach should be enough for you. Once you have understand the approach, you should be able to write your own code. So if you're not in that stage, then definitely something is lacking in you. So you can definitely be in this lecture, understand approach, how we are approaching a question, how we are solving. Once you have understood the approach, you should be able to write the code by yourself. I hope it is very clear and understandable. So now let's move forward. So we will be using, I will be saying you many built-in libraries that we will be using throughout our programming in C++. Like we have many things: reverse sort, length, everything, every built-in function we will be learning. And also header file. One thing in TCS is, it is not like lead code. Okay, it is not like lead code where you will be given the problem statement and one function, maybe function, and you need to just write this function. No, TCS is not like that. So you need to write code from the scratch, from the header file, then you will write your main function, code until written. The whole thing is written by the user in TCS. But in lead code or other platforms, the main function is already handled by them. We will only write the function that they expect us to solve. So TCS, you need to write the whole function. So for C++, we will be using bits/stdc++ .h header file. That is, we will be writing something like hash include bits/stdc++ .h. So this is the header file that we will be using, bit/stdc++ .h, because this is something like import java.util.star. So how util.star, util is a package, right? Inside util library, we will all have all the packages included. So bit/stdc++.h does the same. It will include all the header files. Like there are many IO stream, then you will be having algorithm mat.h. So many header files are there. Everything will be present in the stdc++.h header file. So we'll be including this header file, and we'll also write something like using namespace std. These things are common in every code. Bit/stdc++ using namespace std. I think you already know why do we write all this. Now, so firstly we need to understand, before going into the what we say data structures and all, one thing very important is time complexity of solving a question. So how the question is framed is, see, there will be a problem statement. This is the problem statement. Then you will have something like constraints. If you have ever done some competitive programming or something, constraints he will say like n value, n is less than 10 power 5. Let's say n is less than 10 power 5. What is this n? The n value, the maximum value of n would be less than 10 power 5 only. It will not exceed that. So there are several time complexities. So whenever you have if you have done enough coding in your whole journey, you would have encountered something like TLE, that is time limit exceeded. When does this time limit exceeded is when your code is taking more than 10 power 8 time. That is, if your code is doing more than 10 power 8 iterations, or it is taking that much time, then you will have a time limit exceeded, and this is not acceptable. Then your partial test cases, that is partial test cases, will be accepted. Partial test cases will be accepted based on two reasons. Reason number one is this, that is time limit. Second is logic wrong. When your logic is wrong, then also your code will not work properly. Here you will get wrong answer but not time limit exceeded. Here you will get only time limit exceeded but not wrong answer. Your answer might be wrong, but it is taking very much time to execute the code. So you need to optimize this. So there are several optimization techniques. So first one, we will be learning recursion, where you will be seeing we will be solving something in 2 power n. Then we will optimize this into order of n. 2 power n is very large. For say, let's say n equal to 3. 2 power n would be 8 and n equal to 3. Here you might not understand this. You might say 3 and 8 are very close. 5 is only the difference. Why time limit exceeded is come? Let's say n is 10. Okay, n is 10. If n is 10, then what is 2 power 10? 2 power 10 would be 1024, right? 2 power 10 to 2 power 9 is 5 to 1024, right? See, you see the difference now. 1024 and 10 would be something. This is the difference. Here makes the difference. Previously it was taking 1024 iterations. Now it is taking only 10 iterations. This is the optimization we will do. Okay, got it. Now, what are the various time complexities? There are something like order of n cube, order of n square. Order of n cube is the worst. Before that, order of exponential. Anything in exponential like n power n. Let's say n power n. N power n is the worst firstly. Then n cube, n square. Then you will have something better as n log n. Then you will have n. then you will have log n, then is you have constant. So this is the descending of worstness. So this is the best. This is descending, this is ascending. Okay, these are the various types of time complexities. So majorly we should not cross anything about n square. N square is also many times will give us time limit exceeded. This is the safe spot. Order of n log n, majority cases your code will be submitted. We need to make our code until this. Sometimes order of n square will also work, but these two are something not acceptable. So we have understood about time complexities and everything. Now let's move forward to our first data structure, that is arrays. So arrays are contiguous storage of elements. Let's say this is my array. Indices start from 0. This is my array and size is 6, right? N is 6. So we'll have n minus 1 indices, that is 5, 0 to 5. So we will not use arrays anymore in C++. We will use STL, that is vector. Okay, vectors are dynamic arrays where size is not defined. So we can dynamically increase the size of a array using vector. So I hope you all know what is vector. So declaration would be something like vector of data type and vector name. This is the implementation. For example, I want, let's say this is as my vector as v equal to this. So I will declare something as vector of int v. This is my implementation. So the important functions in vectors are pushback of value. Okay, you will. What is this pushback? Pushback is, let's say if this is your array already filled with 1, 2, 3 and you want to append 4. So you will just write, let's say this is v. You will just write v dot pushback of value is 4, right? So this 4 will be go and appended over here. And the size also will be increased. I am not going into that deep. It's not that important to learn also. So this, and there is something as popback. What is this popback? Here will not pass anything. Popback will remove the last element from the last popback. Then we will have reverse. Reverse of, we will give 2 iterators. What is this iterator? These are pointers. We'll define from what part to what part we want to reverse, from first to last. So reverse, you will do something like reverse nums dot begin comma nums dot end. That is the first and last iterators you will pass over here. V dot begin comma v dot, and there is something like sort. Sort will sort in the ascending order. So you will write v dot begin, v dot end. These are majority, and if you want the size of the array, you can always do v dot size. V dot size, v dot length, both works. Okay, these are few of the things that we have in array. So let's solve one normal question and see how we are approaching the questions. So let me just open the Chrome browser and yep. Here we will taking C++ compiler. Yes. So first time I will say how do we declare our header files and everything. So it is already declared over here. We are using bit/std using namespan std into main. So declaration of vector and everything. So before that, I want you to understand the input format that we would be given in the TCS exam. So discussing that is very important first. So here you would be having what we say problem statement. Then you will have the input format. Input format, you will be getting something like T test cases. Inside that you will taking input. So let's say The question is very simple. Find maximum in array. Let's say this. For understanding purpose, I am just saying how do you take an test case input. First, let's write how do we find the maximum in an array. It is very simple, right? We'll just define the size of the vector, then we will declare of a vector of that size, vector of int v of n. Then you'll take the input. It would be something like for I into equal to 0, I less than n, I plus plus. Here you will write c in v of I. I hope this is everyone know. So what you will do, you will just declare something int maxi equal to 0. Let's say 0, or else you can also let's say only positive values are only there. So let's say you loop into the array for I into equal to 0, I less than n, I plus plus. You will just compare if my maxi is less than the v of I. If my maximum element is less than the array element, then my maximum element will be the array element, right? At last we'll get the maximum element. Here we'll print the maximum element. So let's say my array size is 5, and let's say my input is something like 4 3 1 5 2. Here we should get something like 5 as my maximum element, right? 5 we are getting. So this is a simple code, but he will give something like input format would be something like see, this is we are doing for one test case. So we got n is equal to 5 and the elements were 4 1 2 5 3. Not exactly this, I inputted something, but see, here this is the input format we took something like this, and we are printing 5 as our output. But in exam you will be getting 2. This is t equal to 2. This test case, 2 test cases. So you will get 2 n values. Here for the first one you will be having n as 5, 4 1 2 5 3. This will be your first test case. You will print 5 over here. Then again, let's say 7 number of test cases, 7 number of elements you are getting. 7 number of elements would be 4 1 5 2 3 7 6. These are 7 elements. Here you will print 7 as your output. Understood? This is your first test case. Here is first. You will just loop. That's all. You will just loop over here. So you can just do. Let me just copy this and remove this. Now you will just do. You will take a number of test cases as input. You will write c in t. Then you will loop for that time and times while t minus minus. If you don't understand what is while t minus minus, you can also do like for I and t I equal to 1, I less than or equal to 2. We will do the same task for t times. Paste the same over here. Paste the same over here. This would be the code for that. Now you need to specify for 2 things, right? Now here you can also do. Let's take 8. No, let's take only 3 elements. So 4 7 1. For this the answer should be 7, right? Let's say the answer should be 5 and 7. Let's see 5 and 7 is coming or not. We are getting 5 7 and 0 0 also as our output. Let's see why 0 0 is coming. We have not defined how many test cases we have, so it would be 2 test cases. These are the small things that we generally do mistakes. So 2 number of test cases. First test case n value is 5, corresponding elements. Second test case n value is 3, corresponding elements. 5 and 7 is our output. This is how we take input in C++. Okay, C++ or in anything, you will take test cases as this. So in this you have also understood how do we take test cases as input and basic understanding of arrays. Now let's solve few good level of questions in arrays. We'll solve 4 to 5 questions, and in that we'll learn some new topics, new algorithms and everything. So now let's solve a few questions on arrays to get a better knowledge on arrays data structure. So we'll be solving 4 to 5 questions. These are plain array question. We will be not applying any algorithm or something in this. We'll be solving algorithm questions, which algorithm is something which includes every data structure. So we'll be solving that. So let's move forward to the first question. The first question name is to sum. What does the question say is, so we'll be given an array as input. So this is the array that we have been given as input. So in this array, the problem statement is this: you will be given a target. Okay, this is a target value. The target value is 9. So you need to search in this nums array whether there exist two elements in the array which sum up to the given target. Let's say my target is 9, and if you see 2 plus 7 gives me 9. So you need to return slash print the indices of the given array. So indices are, this would be 0, this 1, 2, 3. So you need to return 0, 1 as your answer for this question. So 0, 1 would be the output of this nums array. If the target is 9, and if you see, let's change our target. Let's say target is 12. So is there any element which sum ups to 12? No, there is nothing like that. So you will return -1, your answer, because there exists no answer for this. So this is a very simple code. So we will be solving this code using brute force approach. There is some better approach which we will be using map data structure. We have not still yet learned what is map data structure. So you will be writing the brute force approach for this. So first let's understand what we can do. So the nums array was it was something like 2, 7, 11, 15, right? 2, 7, 11, 15, and this was our indices. Target was 9. We can simply check every occurrence of 2 with everyone, then 7 with everyone, then 11 with everyone. If there exists anything, we'll get. So it would be something like, let's consider 2. We will, for 2, how many occurrences? Let's okay, target is 9. Let's see for target 9. So it would be 2 plus 7. Is it equal to 9? Yes. For the first time only we got the approach answer. So let's remove our target with 9, and let's say it as let's say it is as 26. Okay, 26 is my target. So you will check every occurrence of 2 with everyone. So is 9 equal to 26? No, this is not the pair. Then you will check 2 plus 11. Is 2 plus 11 13? This is also not equal to 26. Then you will check 2 plus 15. This is also not equal to 26. So 2 occurrences are done. So we did not get 2. Then we will move with 7. We will check every occurrence of 7. So 7 you will check with 2? No, because already 2 and 7 pair is done. Why you will again check with 2? So you will check with 7 and 11. 7 plus 11, 18, not equal to 26. Then 7 plus 15, 22, not equal to 26. So 7 occurrence is also done. Now you will check 11 occurrence. 11 plus 15 is equal to 26. So you will return 2, 3 as your answer. Now if your target was 30, then there is no element. You will return -1, -1. I hope it is very clear. For this, the pseudocode would be something like, you will go from, for I equal to 0 to last n -1. Then you will go from I equal to j equal to I plus 1. From, if you are at 2, you will start from 7, right? So it would be I plus 1. Then you will go up to n and check. What you will check? If v of I plus v of j, if is equal to my target, if it is equal to my target, then print those I and j. Even after complete loops, if you did not encounter anything, then print -1, -1. This would be my pseudocode. Let's write the code for this. So it would be, we want the test cases, int t, int c int t. I generally like writing while t minus minus rather than writing for int I equal to 0, I less than t. So we will get n as our input, the size of the array. Then let's take the vector as input. It would be of n size. Then it would be for I int I equal to 0, I less than n, I plus plus. We'll write c in v of I. Now we'll check for I int I equal to 0, I less than n minus 1, I plus plus. For int j equal to I plus 1, j less than n, j plus plus. Here we'll check if v of i plus v of j is equal to target, then we can print those I and j's and break over here. So we also need the input for target. So let's say into target, c in target. Okay, now we can keep something like bool found equal to false, that we have got our answer. We'll update our answer bool as here. So we can write found equal to true over here. So we got our answer. At last we'll just check if my found is equal to still false, then I'll return -1 comma -1, and we'll write a return 0 at the last. This is a simple code. Let's give our input. The input was one test case only we are testing for one test case. The size of array was 4 and the elements were 2, 7, 11 and 15. For this we should get 1 comma 2. We did not give the target value, right? We also want the target. So we want target. Target would be 9. Okay, we can't do something like this. Let's send them in strings. No problem. See what -1 comma -1, because it should be a unary operator, but we are sending in binary, so it should be double quotes, not single quotes. It will work fine now. Const invalid operator -1 comma -1. Oh, single angular bracket we have given, right? So we need to get 0 comma 1. We are getting 0 comma 1. And now if we change our target to, second target was something like 36 we have taken, right? We need to change here, right? 36. For 36 we were getting 2 comma 3 as our answer. Let's see if 2 comma 3 is getting or not. Here we are getting -1 comma -1, but it should be, so it is not 36, it is 26. Sorry, 36 is not existed only. No, 36 will not get, because maximum sum is only 26. So how we will get 36? 26 is, we are getting 2 comma 3. Everything is working fine. If there is nothing like we'll never get 40, so for this case we will get -1 comma -1. That is perfectly fine. -1 comma -1. Now if you understand what is the time complexity of this code, the time complexity is we are looping inside looping, that is order of n square. So this is a brute force approach, and if your size of array, let's say it is more than 10 power 5 or 10 power 4 even, you will get time limit exceeded for this code. So we need to optimize this. So for this optimization we will also read one more data structure, that is map data structure, where we can solve this question in order of n. We will discuss this question again later when we learn the topic such as map data structure. So this is a simple code that we can understand for some problem. Now let's move forward to the next question. So the next question was something like move zeros. So this is one very interesting question. So we have been given an array. In this array there are zeros, right? So we need to move the zeros to the end. That is the question. So the output would be something. The relative order should be matrix. So 1 comes first, so 1 is 1. So 3 comes 1, 3. Then you have 12. This should be the relative order, and how many zeros are there, that will go to the last. This is the output. How we can tackle this question? So it was something like 0, 1, 0, 3, 12. So you need to get something like 1, 3, 12. The non-zeros should maintain the same order and the zeros should go to the last. This is the question. How we can do this? I would say this is very simple question. So what we can do in this is, it was something like 0, 1, 0, 3, 12, right? It was 0 1 0 1 0 3 12. It was something like this. And also write its indices 0 1 2 3 4. N is 5 over here. Okay, N is 5 over here. What you can do, you can simply make a temporary array of same size. So 5 elements. Okay, now first time you traverse into this. So if we traverse, keep zeros count. So we have encounter 1 0, so increment it with y. 1 we came here, not a 0, leave. We came here, so 2 zeros we got. Come here, no 0, no 0. So in this array we have 2 zeros. Now we have calculated the number of zeros. Again you iterate over this. Once non-zero has encountered, so here you are there. It is a 0, don't touch it. Here 1 you got, so 1 is non-zero, then place it over here. So 1 comes here. Then again you will go to 0, leave. 3 comes, 3 push here. 12 comes, 12 push here. Then the remaining elements will be 0. This is a simple approach that we can follow. For another example, let's say it is something like 5 0 0 2 3 0 1. Let's say this is my array. So first thing is you will count the number of zeros. The number of zeros are 3. You will make same sized array. Now 5 will be copied over here, 2 will be copied here, 3 would be copied here, 1 would be copied here, and 0 0 0. This is a simple approach that we will follow in this question. So let's write the code for this. If we write the code, we will easily understand what we are actually doing. So up to here the code is same, right? We are taking the test cases, the size of the input, vector int this. Now we'll calculate the total number of zeros. We can write, or while taking the input also you can do, you can do int x in x v of I is equal to x, and you can just check if v of I is equal to 0, then zeros plus plus. Here only you can define int zeros equal to 0. It will give my zeros count. Now we want another temporary vector of n size only. Now here we will do for int I equal to 0, I less than n, I plus plus. int I, now we'll check if my v of I, and we want another int I dx equal to 0. Okay, if v of I is not equal to 0, if my value in the original array is not equal to 0, then what I will do, in the temporary index I will store that v of I value, and I will do my index plus plus. Okay, this will fill my array in partial way. Now zeros will not be filled. For filling the zeros, I can just do for int I equal to index I less than n, I plus plus, I can definitely do temp of I is equal to 0. This will give my complete code. The code is done. Now we can just print my, for int I equal to, I can print my temporary array. It will have the array in the order which we want. So we can do cout temp of I. Let's give a space, and here we will print a new line. Now let's see. It was something like the size of the array was 5, and 0 1 0 3 12. 0 1 0 3. For this the answer should be 1 3 12 0 0. vector of int, sorry, we have written vector spelling wrong. Where is that? Vector of int. Now it should be fine. I less than temp, no, I less than temp, no, it should be I less than n. It should be I less than n because size is n, not temp. Temp is an array. 1 3 12 0 0. We are getting perfectly that. Now if you want, I can dry run this, or else we can skip this part. Okay, let's dry run what is happening. One second. I don't know for what reason it is not getting. So okay, I can dry run this over here only, no problem. Here it was getting int number of test cases is 1. Then here we are counting the number of zeros. Then if my v of I is 0, then I am doing a 0 plus plus. I am creating a temporary array. In this temporary array, I will store a relative order in which the arrays came. If my coming element is not equal to 0, then it would be part of the element because it is the first element that appears in my original vector. So I will add it to my temporary array and I will do a index plus plus. Then last I will just print my temporary array which will have the relative order first and the zeros at the last. So this is a simple code that we can understand. Now let's move forward to the next question. So the next question is something like, what is the next question? Moving forward to the next question. This is done. The third question is sort colors. So this is one interesting question. Sort colors is, here we will having only three elements that are zeros, ones and twos. Only these three elements only will be present in my array. So this should be sorted into 0, 0, 1, 1, 2, 2. The 0 should be first, 1 should be 1. This sorted elements we know, right? So what you can say, you can just say I will use the inbuilt sort function. I will write sort v dot begin, anything, the array name nums dot begin or v dot begin, v dot end, and I will submit. Yes, this works, but when the constraints are low, only then this will work. The interviewer is not that lenient or something to give that easy question that using the inbuilt function you are able to solve. It is not something like that. You can use the inbuilt function, but it might be prohibited or the constraints are very large. So he expects you to solve in order of n time complexity. We can solve this in order of n, order of 3n basically, or order of n anything. 3n is constant, so we will consider it as order of n only. So how can we solve this question? It was something like 202.110, 202.110. This was my array, right? So let's even write its indices: 0, 1, 2, 3, 4, 5. 6 sized array. N is 6. Okay. Now you can take 3 variables as this. So it would be 0, 1, 2. These are the variables. Initially everything is 0. Now you will go 2 came, 2 incremented. Here you will go 0 came, 0 incremented. Here you will go 2 came, 2 is incremented. Here you go 1 came, 1 is incremented. Here you came, sorry, I incremented 0, right? So 1 is incremented. Here you came, 1 is incremented. Here you came, 0 is incremented. So the frequency of 0 is 2, the frequency of 1 is 2, the frequency of 2 is also 2. Now you can simply do iterate over my array. First you place how many zeros are there, then you place how many twos are there, then how many twos are there. You can simply place that. So number of zeros are 2, so you will place 2 zeros. Then you will see number of ones are also 2, then you place 2 ones. Then you will see number of twos are also 2, then you will place 2 twos. This, if you take another example, like let's say 2 1 0 0 0, 1. Let's say this is my array. So you will just see zeros are 3, ones are 2, twos are 1. So you will do resultant 3. First zeros will come. So you will keep 3 zeros, then 2 ones, then 1 2. This will be my array. So you will just count how many are there, then you will iterate that many times and append this. That's all. Very simple question. Let's write the code for this. So so this would be simple, right? Now let's say for int I equal to, okay, I removed the input part also. I less than n, no problem. We'll write it again, no issues. So now I will iterate over my same array. I can show you another way of writing for loop also, that is for each loop will write. So what is the type of the data type? Int, right? We will write int x or something, any value in what array name is v. So we'll write. Now this x represents v of that index. So you will just say if x is equal to 0, then you do zeros plus plus. Else if x is equal to 1, ones plus plus, else twos plus plus. Why you are writing else? There are only 0, 1 and 2 only in the input. So we'll write int ones equal to 0, comma 2's equal to 0, comma 0's equal to 0. So we are iterating over my array, calculating how many zeros are there, how many ones are there, how many twos are there, incrementing them. Okay, now I will iterate over my array equal to 0, I less than n. No, we can't do like this, because see, first I want to place the number of zeros. So it would be something like int idx will start with 0. I will write while my zeros are greater than 0. I can write while zeros minus minus also, or you can do for int I equal to 0, I less than zeros, I plus plus, and you can do v of idx equal to 0 and idx plus plus. This is one way of writing. Or you can also write something like, now you will write for I equal to 0, I equal to ones, I plus plus. You can remove this, and you can plus plus here also we can write, and this would be 1. Or else you can also do while my twos minus minus v of idx plus plus is equal to 2. Everything means the same. Now you can just print your for auto it in your v print it with a space, and lastly you can give an end line. Now everything we have not changed the input, right? It will give a wrong answer. So the elements were 6, right? 6, and the input was 2 1 0 0. No, it was not the input. 2 1 2 0 2 2 0 2 1 1 0. For this the answer would be 0 0 1 1 2 2. 0 0 1 1 2 2. Everything means the same. These three statements represent the same. Just what is different is the way how we write is different. So this question is also easily done. So let's move forward to the next question. So the next question is rotate array. This is one very good type of question, and we'll also learn the STL functions over in this. So rotate array. We have been given this array. Let's write its indices. It is 0 1 2 3 4 5 6. So n is equal to 7, and if you see k is given, so we need to rotate the array by k steps. So what is this rotation? So if you understand, this is 1 2 3 4 5 6 7 and k is 3. We need to rotate this array by k steps. That is this 5 6 7. Why this 5 6 7? 5 6 7 is the last 3 digits. This comes front. So it would be 5 6, 7, 1, 2, 3, 4. This is what? K steps rotation is this. So the last 3 digits will come to the forward and 1, 2, 3, 4. We need to do something like this. How we can do this? So very easy. The intuition is very simple for this. Let's move forward to the next page and I will understand. See, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 and K is equal to 3, right? So the intuition is something like, first reverse the whole array. Once you reverse the whole array, it would be something like reverse. It would be 7, 6, 5, 4, 3, 2, 1. This is done. Now we want the expected output was 5, 6, 7, 1, 2, 3, 4. Okay. Now reverse first k elements, not 3, first k elements. So it would be first k elements is 3, right? 7, 6, 5. If you reverse, it would be 5, 6, 7, 4, 3, 2, 1. This first half is done. Now very easy. You reverse this part. It would be 5, 6, 7. If you reverse 4, 3, 2, 1, it should be 1, 2, 3, 4. 5, 6, 7, 1, 2, 3, 4 is done. So the approach is first reverse completely. Reverse begin to end. Begin to end. Now second, reverse begin to K. Next, reverse K2 and the answer is solved. This is a simple approach that we will follow. So we will see how we write the HTL functions over here. So we want the input and at last we also want to print our array, right? So we'll just remove this part. So this printing also we want, input taking also we want. So firstly we'll reverse the complete array. It would be v dot begin comma v dot end, right? And also we want k, int k. So in k we want k also. Now reverse, here you can do v dot begin comma v dot begin until what? Until k elements. So we'll write begin से लेके k elements तक, we'll write that. So begin plus k, and then we'll reverse. The beginning pointer is v dot begin plus k. V dot begin plus k to v dot end. We'll reverse up to end. Then we'll print our this. So let's run. Before running, it was 1, 2, 3, 4, 5, 6, 7, and the elements were 7, and k value was 3, and k value was 3. It should be 5, 6, 7, 1, 2, 3, 4. Let's see, submission is good. We have written wrong. It should be reverse, not reverse. It should be 5, 6, 7, 1, 2, 3, 4. 5, 6, 7, 1, 2, 3, 4 we are getting. So when you solve for higher test cases, always remember do k equal to k mod n. Why? Because why we are doing k equal to k mod n? I will also explain you that. K equal to k mod n. What does this specify? Let's say my size is 3. Okay, my size is 3. Let's say 1, 2, 3. If you rotate this by k equal to 1, it should be 3. First you will reverse completely. So it would be 3, 2, 1. Right? Then you will do k steps. So it would be 3, 1, 2. This would be your final answer. But when you see, if your n is 3 and you are doing k equal to 7, if your k is only greater than n, what is k equal to 7? K equal to 7 is nothing but k equal to 1. Because if you do 3 times, if n is also 3 and k is also 3, don't you think the answer will be again the same original array? If it is 1, 2, 3 and you rotated it by 3 steps, again it would be 1, 2, 3. If you rotate it by 6 steps, again it would be 1, 2, 3. So for every k equal to k mod n iterations, it will always lie less than n only. So k can never be greater than n. So that is why we write k equal to k mod n. So I hope it is very clear why we are writing k equal to k mod n. If we also run, it would work finally, because 3 equal to 3 mod 7. 3 mod 7 is again 3 only. So it would be k equal to 3 only. If my k value is greater than n, then only it would be helpful. That is a just optimization technique. So these are the few questions that we solve using basic arrays. Now we will include few algorithms in this and solve the other questions. Let's move forward to the algorithm section. Like we'll solve using two pointer, prefix sum, everything, cadence algorithm, sliding window, everything we'll see in the next. Now let's move forward to the next approach, where we will be discussing how we can apply two pointer approach and what is two pointer approach. So this two pointer approach is to be applied in maybe strings, arrays, everywhere. So let's understand how two pointer approach. What is this pointer? Is nothing but not this pointer, not referencing pointer. This is two pointers, is two variable approach. So we'll use two variables to solve this question. So two sum, you have said that two sum is already completed. Again we are seeing, so there is a variation in this question. So the when the input array is sorted, we can do something better than n square. We have solved two sum in order of n square, but using two pointer approach we can do it in order of n in worst case, but in majority, average and best case we can do in order of n by 2 only. So best case is order of n by 2 or order of 1 also, but let's understand order of n is, you just think we are doing is in order of n time complexity. So how can we solve this question? Let's see. When the input is sorted, you can always use the two pointer approach. This is the array given for us and the target is 6. So what we previously done, we have checked 1 with everything, 4 with everything, 5 with everything, 9 with everything, 11 with everything, 22 with everything. So if we get anything, we will just return its indices. But in two pointer approach, what we'll do is we'll place first pointer I at the beginning and the last pointer j at the end. We'll compute the sum of them. So 1 plus 22. So if you see 1 plus 22, 1 plus 22 is 23. You will always compare your sum with your target. Your target is 6. Is your 23 greater than target, less than target, or equal to target? If your sum is equal to target, then I and j are that index which are possible for that answer. No, in our case it is not equal, it is greater. So if you are greater, you want to decrease your sum, right? If you want to decrease, you will do I plus plus or j minus minus. As it is sorted, if you decrease the larger element, the sum also gets decreased. So I'll do a j minus minus and I came over here. Now I will compute my sum again. Is 1 plus 11. What is 1 plus 11? 12. Is 12 equal to target? No, 12 is not equal to target. Is it less than target? No, it is greater than target. So again I will decrease my j. Now you will see 1 plus 9. 1 plus 9 is 10. It is again greater than my target. So you can just skip. Now you will do 1 plus 5. What is 1 plus 5? 1 plus 5 is 6. So 1 plus 5, 6 is equal to target. So return the indices 1, 0 and 2. So you will return 0 and 2. So this is the approach we will be following. So for the next test case, if you see 0, 1, 2, 3, I is over here, j is over here, target is 14. So 2 plus 23 is greater. So you will do j minus minus. 2 plus 11, 13. 13 is less than 14. So you will do a I plus plus. Now you will see 7 plus 11, 18. 18 is again greater than 14. You will do j minus minus. Now you will do 7 plus 7. 7 plus 7 is 14. So, but we will not take the same element twice. So here we will break out. Here we will break out. So here we will return minus 1 comma minus 1. If my if my target is 13, we will not get. If target is 12, we will not get. Sorry, 13 is available, 2 plus 11 is but if it is 12, we will not get, sorry. So this is the simple approach. Let's write the code for this. So taking the input is done. So we will declare two pointers, I equal to 0 and j will be at the last. So it would be last index n minus 1. I'll just do while I is less than j. So we can calculate until I is less than j, we can calculate in sum will be v of I plus v of j. Now we will have three conditions. If my sum is equal to target, we want target also as our input. So we can take target c in target. If sum is equal to target, then we can print the I and j index and we can break from here, right? We can also keep something bool found equal to false and found equal to true, right? we don't want to print our array, so let's remove this. And here we'll see else if my sum is less than target. If my sum is less than target, what I should do? I'll just do I plus plus, or else the other case would be just j minus minus. At the last, even after the while loop, if my found is still false, then I will return a minus 1 comma minus 1, that there is no element which is satisfying the condition. So our input was something like how many size? 6 sized array. So it was 6 sized array and the elements are 1 4 5 9 11 22 and target was 6. So we need to return 0 comma 2 as our index. 0 comma 2 is printing. For another test case it was 4 numbers, 2 7 11 and 23. Target was 14. Minus 1 comma minus 1. But if we do less than or equal to, you will get 1 comma 1. 1 comma 1, because we don't want to take the same elements. If the constraint is you can pick same elements, then you can keep equal to. But our case is we don't want the same elements, so we'll just write I less than. Here we'll get minus 1 comma minus 1. These are the few things that you need to keep in your mind while solving the question. So this is done. So let's remove this and move forward to the next question on the two pointer approaches. So two pointer approaches we have understood how to this. Now the second question is reversing a string or checking for palindrome or thing. So what is palindrome? You know already, right? If the reverse is equal to original, then it is known as palindrome. We already know about this. So I don't think I even also need to show. See, let's say s is equal to, I think this is very light, so let's take our original this color only. So s is equal to, let's say s is equal to Monish, and if I want to reverse or check for palindrome, I can just do I j. Let's check for palindrome. I hope you can easily do reverse. I will just check, is my first element and last element is equal? Is my s of I is equal to s of j? If it is not equal, then it is not a palindrome only. So m and h are not equal, so Monish is not palindrome. But if you check madam, M-A-D-A-M, now I is here, j is here, both are equal, so I is forward, j is forward. I is A is also equal. No, both are equal, so madam is a palindrome. And if you check for race car, R equal, A is equal, C is also equal, E is left, so race car is also a palindrome. Let's write a quick code for this. So I think we have not read strings, right? So we can take in, let's say we'll compare array elements only. So we can int I equal to 0, j equal to n minus 1, while I is less than j. Here we'll check if v of I is not equal to v of j, then see out not a palindrome. row, print a end line, and we can return a 0 from here. Or else I will do I plus plus and j minus minus. After the while loop also we have not written, then we can print it is a palindrome. This would be a simple code, and let's say this should be not a palindrome. This 14 should not be there. 14 should not be there. This is not a palindrome for sure. So what would be a palindrome? 1 to 2 1 would be a palindrome, right? Let's say 1 to 2, not a palindrome. So for 4 size, we can do 1 2 2 1. This is a palindrome. So it should give palindrome as output. It is a palindrome. So if we also give 3 over here, and it should be 5, it is also a palindrome. It is a palindrome. So it is working perfectly fine. Let's move forward to the next question. It is some good question, good level of question. So remove duplicates in a sorted array is the question. So till now we were doing questions on opposite direction. So I pointer is going from here and j is coming from here. This is 2 pointer which we have learned. But 2 pointer can be also in same in forward direction also. Here it is I, here it is j. This is also possible. Let's see. We need to remove the duplicates in a sorted array. So what is this question saying? Let's understand it first. So we need to remove the duplicates in a sorted array. So if you see, the approach is very simple. Put a let's say I pointer over 0 and j pointer from 1. So we will always check if my v of I is equal to v of j, then I will just skip that element, or else when I encounter a new element, I will just put that. If you see, now I is at 0 and j is at 1, right? I will check, is my v of 0, that is v of I, is equal to v of j? Firstly, I will put 1 0 over here because it is the first element, and it, no matter what it is repeating or not, we'll put that. Now you just say 0 is equal to 0, so move j forward. Now we encountered 1. 1 is a new element, so increment I, and at the place of ith pointer you can put 1 over here. Now increment j. 1 and 1 are again equal, don't. 1 and 1 are again equal, do. Now we got 2. If you got 2, now first do I plus plus. If you do I plus plus, I would be pointing at the second index. At the second index, just put 2. Now j forward. 2 is again equal to 2. 2 is again equal to 2. Now you encountered 3. Now do a I plus plus and put a 3 over here. Now 3 is again equal to 3. Now you got 4. So 4. This would be my final array by removing the duplicates. So let's write the code for this. This is very simple. It is both are going in the same direction. So if I write the code, you will easily understand. So I is equal to 0 for int j equal to 1, j less than n, j plus plus. Now we will make modifications in the original array only. So if not, we can also take temporary array. So let's first try in the original array. We can just do, if my v of I is not equal to v of j, first thing is I will do I plus plus, and in the v of I will put the v of j. This is a simple thing I will do. At last we can print for auto it in v cout it. You may also see other values because we are updating in the same. Let's see, we can also do in temporary array, but I want to show you in the original array only. So how many elements are there? 10, right? 10. So 0 0 1 1 1 2 2 3 3 4. It should be 0 1 2 3 4 at the starting. 0 1 2 3 4. Ignore this because we are modifying in the same array. So ignore this. 0 1 2 3 4. These are the things. From these elements you can remove them also, or you can use extra space. But this is the question. So one thing is very important. You can only apply this approach when it is in a sorted order only. So this is about two pointer approach. So two pointer approach may be in opposite direction or in the same direction. In any direction we can apply two pointers. So next we will move forward to the next thing and understand how we can solve questions in that. So every number is represented in the form of bits. So let's say every number is represented in the format of zeros and ones, because we already know computer only understands zeros and ones. So it is always represented in the powers of 2. So let's say example as 11. If you want to represent 11 as bits, you can represent in the format of 8, 4, 2, 1. These are the powers of 2, right? So this is 2 power 0, this is 2 power 1, this is 2 power 2, 2 power 3. Why did you take only up to 8, 4, 2, 1? There is 2 power 4 also, everything. But 2 power 4 is 16, but it lies between 11 and 16. That is 8 and 16, right? So 16 is not required, so we are not taking. It would be 0 anyways. We will understand how we are taking. So we need to represent 11. So 8, 4, 2, 1. Set bit represents 1, unset represents 0. So to form 11, you want 8, you want 2 and 1. This is 0. So 11 would be represented in the format of bits is 1, 0, 1, 1. This is 1, 2, 4, 8. 8 into 1 is, this is 8 plus 0 plus 2 plus 1. This is 8 plus 3, that is giving us 11. So this is the format in which every number we can represent in the format of bits. So this is very clear. Now, first thing that we will be solving is to check a number is divisible by 2 or not, that is even or odd. So how we can check that? So you might think that we can use the modulo operator, but how can you apply modulo operator on bits? So there is a simple, bits are very faster compared to any operation in programming or anything, because they operate on bits. So to check a number is given even or odd, let's say 11 only we want to check, and also 16 we want to check, and 19 also we want to check. These are the numbers that we want to check whether they are even or odd. Let's derive the formula. So first thing is 11. 11 is represented as 1, 0, 1, 1. So before, you need to know few operations. Let me discuss them. So there is bitwise operators. What are bitwise operators? There are majorly 3, but many more. Left shift, right shift, I am not covering right now. See, first one is bitwise, or next one is bitwise, and next one is bitwise XOR, which is also known as exclusive OR. So let's understand how these are operated. Let's say bitwise OR. The truth table would be if either one bit is set, the whole resultant is set. Let's say, so it would be for 2 inputs. Let's say it is true, false, and we want to calculate the OR among them. So if 1 or 0 gives us 1, 0 or 1 gives us 1, and also 1 or 1 will also give us 1, and 0 or 0. If none of the bits are set, then the resultant is 0. Coming to AND, both the bits should be set. That is 0, 0 will give you 0, 0, 1 will give you 0, and 0, not 0, it would be, sorry, it would be 1, 0 will also give you 0, only 1, 1 will give you 1 in AND. Let's go for XOR. If both the bits are same, that is 0, 0 is 0. The both bits should not be the same. Whereas 0, 1 would be 1, 1, 0 would be also 1, and 1, 1 give 0. The symbol for OR is the pipe symbol. One single straight line. and is, we already know and is and XOR would be this cap symbol. So it would be A or B, A and B, A XOR B. These are the things that we follow. This is a naming convention. So we have understood how to check. Now let's move and understand how even or odd is checked. So it would be very simply something like it would be 100. If you want to check if the given number is even or odd, do the AND operation with 1. So 1 is represented with 0 0 0 1, right? Do the AND. So 1 and 0 is 0, 0 and 0 is 0, 0. So the n and 1 is equal to 1, then it is odd, and n and 1 is equal to 0, then it is even. If the LSB, that is left significant bit, is 1, then the given number is odd. If the left significant bit is 0, then the given number is even. Let's check for 16. 16 would be simply 84200. 8421 only gives us up to 15. For 16 we want new thing, so it would be 168421. So 10000 10. Now do AND with this with 1, 00001. So it will give you 0. So n and 1 give you 0, so it is an even. Similarly, you can check for 19. 19 would be 168421, right? So we want 16, we don't want this, 1 1. So do AND. So this is 00001. Again the left significant bit is 1 again, so this is a odd number. So we have understood how to do the check for even and odd. Very sorry. Now let's drag this somewhat down, because okay, power of 2. So power of 2, how do we calculate? How do we calculate power of 2? So what is power of 2? We need to check. If it is 8, we'll return yes, because it is a power of 2, because it is 2 cube. If it is 17, we'll say no, it is not a power of 2. So how do we check? The formula for this is n and n minus 1. So you will do an AND with n and n minus 1. So let's say 16. For this the answer should be correct, right? So you do 16 and 15. If it is equal to 0, then it is a power of 2. So 16 would be 1 0 0 0 0. 15 would be 0 1 1 1 1. 16 8 16 8 4 2 1. So this is 0 0 0 0 0. N and n minus 1 is 0. Similarly, you can check for 32 also. 32 would be 1 0 0 0 0 0. And 31 would be 0 1 1 1 1 1. You understand? It is similar pattern. But if you check for 17, it will not give you 0, because it is not a power of 2. 17 would be 16 and 1. 16 8 4 2 1. So we have taken one extra 0, right? Let's remove that. So it would be 16 8 4 2 1. So 17 would be 1 0 0 0 1, and do the AND with 16. So it would be 16 would be 16 0 0 0 0. So here it is giving 1 0 0 0 0 0. So is it equal to 0? No. So 17 is not a power of 2. So we have understood how to write power of 2. Now let's just first code the power of 2 and checking for even and odd to understand are we doing it correct or not. Now, so we wanted what we wanted. So we want int n as input, cnn. First we want check for even and odd. So it would be very simply we'll check if n and 1 is equal to 0, then we'll print even, else will print odd. Let's check. Let's remove everything. For 10 it should give even. It is giving odd. N and 1 is equal to 0. What? Sorry, n and 1. What did we write? Are we just confusing ourselves? So it was something like, where is my iPad screen? Where did my iPad screen vanish? 1 second. Let me just get my iPad screen for a moment. Yes. So n and n minus 1. 10, right? It was 10. Let's do in the 10 next 10. So it was 10. 10 was represented as 8, 4, 2, 1. So it was 1, 0, 1, 0. 1, 0, 1, 0 is 10. And we will do AND with 1. 0, 0, 0, 1. So it is 0. This is also 0. This is also 0. This is also 0. If n and 1 is equal to 0, then we need to get even. Yes, we have written the code correct. If n and 1 is equal to 0, then we should get even. Why are we getting odd? Odd? Again odd? Are we taking something wrong? Int n. If n and 1 is equal to 0, then we should get an even. Correct? Correct. Even. That was just because it was calculating something else, I guess. It was some braces issue. If n and 1 is equal to 0, or else you can say n and 1 is not equal to 0, or you can do equal to 1 is equal to 1. Here you can print, or the logic is correct, because when we do it with pen and paper, it will definitely give it correct only. Or else you can, else if n and 1 is equal to 0, then it should give us some extra base came, I guess. Then it should give us even. Even this should work because both are same. It should give us, okay, no, okay, one extra base came actually. Even. The thing is perfectly fine. The logic is perfectly fine. Now we need to write for 2 power n, right? That is, if it is check for power of 2. Power of 2 is, if it is 8, 16 something, then so it would be something. If n and n minus 1 is equal to 0, then see out power of 2 end line, else see out not a power of 2. 10 is should not be a power of 2. Let's see. Not a power of 2. And 16 should be a power of 2. Is a power of 2. So this is also done. Now let's move forward to the next question, which are very important. The questions which I have taken now is very important. So the third question is count number of set bits. This is this question I just taken because this is a STL function. I said you I will also explain you the STL functions that help us to solve questions very quickly. So if you see, for 10 it was 1010, right? So the question might be saying like count the number of set bits. What are set bits? The number of ones in a given number. So you can use the direct library function, that is underscore underscore built-in pop count of n. So it will give you. So you can write cout underscore underscore built-in underscore pop count of n. This will give you number of set bits. So for 10 it were two set bits, right? we need it is built in, not built I. It is built in set count. So for 10 16, so 16 is only 1 because 16 is 1 4 zeros, but if you see for 10 it will give 10 two set bits. We are getting 2, but here we are getting 2. So you can also see its implementation because it's not that important. You can just, you will iterate over your whole, you will extract the last bit and it will just check if it is equal to 1 or not. It is very simple. You can just see it is only one SQL function, that's why I covered. So built-in pop count will give you the number of set bits given in a given integer. Now fourth question, very important question, non-repeating element. So here we will understand the importance of XOR property. See, we have not yet read what is map data structure, but we can solve it using map data structure very easily. So here, if you see what is this non-repeating number question is, 2 is having its corresponding, 2 is repeating, 3 is having its corresponding, 3 is also, 5 is only the single number which is not getting repeated. How can we solve this? This is very simple. We can use the XOR property over here. So once you see, there are two properties. A XOR A gives you 0 and A XOR 0 gives you A. Let me prove them for you. See, let's say 7 XOR 7. What does 7 XOR 7 give? I already said you, XOR always represents 0 when the values are same. XOR represents 1 when the values are different. So 7 is nothing but 1 1 1 1 1 1. You XOR 1 XOR 1 1 1 XOR 1 0 1 XOR 1 0. So A XOR A gave you 0. Now do 0 XOR 7. 7 is 0 XOR 1 1 1 1. Understood? I have proved this very clearly now. So how can we apply this now? So you just do XOR of the whole array. So you will do 2 XOR 3 XOR 5 XOR 3 XOR 2. Now I can write, it is a distributive property. You can distribute XORs. So you can do 2 XOR 2, I will have one pair XOR, and I will also have 3 XOR 3 XOR 5. I can definitely write like this. 2 XOR 2 is 0. 0 XOR, this is again 0. 0 XOR 0 gives you again 0. 0 XOR 5. What is 0 XOR 5? 0 XOR 5 is 5. So 5 is that element which is not repeating. This is how you will simply solve the question. So you just need to XOR the whole array. Every same things will get cancelled as they are zeros. Now this will 0 XOR 5 is 5. 5 XOR 0 is again 5. So this is how simply we can write the code for this. Now let's write the code for this and understand how it is done. So we want a vector for this, vector int v of n for int I equal to, for int I equal to 0, I less than n, I plus plus, c in v of I, and I'll int, no, we can also do, what we can do, int XOR equal to 0. Okay, XOR equal to 0 for int I equal to 0, I less than n, I plus plus, c out, what n out, c. We want the single element, right? We can always do XOR XOR equal to v of I, right? Now we can print this XOR. This will have the single element. So the size of the array was 5 and 2 3 5 3 2. We should get 5 as our input. We can't use XOR because it's restricted. So we can do x run. 5 is the single element that we were getting. So if there is no let's take 5 and 4. Now we have added two elements, so 7 would be, so 4 is the single element. Let's see 7 is getting or not. 4 is getting or not. 4 actually appear. Now moving forward to the next question. Swap two elements. So many people already know we can use temporary variable to swap elements. So let's say a equal to 7, b equal to 5. We'll declare temp. We already know how we can swap. Temp equal to a equal to b equal to temp. This will swap for us. So temp equal to a is 7, a equal to b is 5, b equal to temp is 7. 5 comma 7 swapped. Another way is also there. A equal to a plus b equal to let's see, we don't actually remember those. A equal to a plus b or 7, we will always derive a equal to 7, b equal to 5. So first one will be a equal to a plus b. A equal to a plus b is 7 plus 5 is 12. So I want 7 over here, so I will do b equal to a minus b. A minus b will give me 7. Okay, and again I will do a equal to a minus b. A minus b will 12 minus 7 will give 5. A equal to 5 and b equal to 7 swapped. So even this way would work. A equal to a plus b equal to a minus b, a equal to a minus b also will swap. This is with no extra variable. We can use the same thing in the XOR also. We can do a equal to a XOR b equal to a XOR b, again a equal to a XOR b. We'll get. So it was 5 and 7. Na? A equal to 5 XOR 7. What is 5 XOR 7? 5 XOR 7. 5 would be 1, 0, 1. 7 is 1, 1, 1. So this is 0, this is 1, this is 0. So this is 5 XOR, this is 4, 2, 1. So a is 2 now. A is 2. Now we are doing b equal to a XOR b. So 0, 1, 0. XOR b is the same. We did not change b, right? B is 5. So again we will do 1. So no, b is 7. Sorry, b is 7. B is 7. So this would be 1 and 0, again 1. So we got 5 in b. So b is 5 now. B is 5 now. Again we are doing a XOR b. A XOR b is 2 comma 5. 2 comma 5 and assigning to a. 2 is 0, 1, 0 and 5 is 1, 0, 1. Do XOR 1, 1, 1. A is 7. So the formula for XORing, swapping two numbers using XOR is a equal to a XOR b equal to a XOR b, again a equal to a XOR b. I have said you three ways: using a temporary variable, without using a temporary variable, using math addition, and here using bit manipulation. So the missing number, last question that we will be discussing today is missing number. So it was 6th question, right? Yep. Missing number. And example was 0, 1, 3. We want to find the missing number. So we can clearly see 2 is missing over here. So we will have the numbers from 0 to the n. There will be exactly one missing number and we need to find that missing number. So it is very simple. You loop from 0 to that n. Okay, 0 to n you loop and find out the XOR of every element. So it would be 0 XOR, 1 XOR, 2 XOR, 3 XOR, up to n, XOR n. Right. Do that XOR with these elements. So it is 0, 1, 3. Now common will go. Only the thing which is left, that is 2, that will return. So for example, let's say n is 3, right? Here n is 3. So we'll do from 0 XOR, 1 XOR, 2 XOR, 3. This is one result. Make this result XOR with the elements that are present in the array. That are present in the array is 0, 1 and 3, right? 0, 1 and 3. Now if you do 0 XOR, 1 XOR, 2 XOR, 3 XOR 0 XOR, 1 XOR, 3. 0 XOR 0 gives you 0 only. 1 XOR 1 gives you 0 only. 3 XOR 3 also gives you 0. So 0 XOR 2 gives you 2 again. So the missing element is 2. This is how we can simply solve this question. Let's write the code for this and wrap up bit manipulation. So we definitely want whole code is same actually. So here we will XOR with I Now x has that. Now again I'll loop for int I equal to 0, I less than n, I plus plus, xor equal to v of I. At last we'll print x. Here the input was 3013. For this the answer should be 2. Semicolon is missing. I hope it is very clear what we are doing. We are getting 1. Let's see why we are getting 1. So this will give me everything from okay. The array size would be 4, right? Yes, the array size would be 4. Yes, the array size would be 4 because we are missing one element. So 0, 1, 2, 3, we are missing 2. So 2 was not there, that's why we are getting 1. So it is very clear how we are getting 2. So this is how we can wrap up bit manipulation. Now let's move forward to linked list, and we will solve few questions on linked list and then move forward to some other algorithms such as greedy, prefix sum or something. Done. So let's move forward our discussion, and the next topic is that we would be discussing is searching algorithms. So what are the searching algorithms? So basically there are two types of searching algorithms. One is linear search. Second one is binary search. Binary search. In this binary search, this linear search, everyone is aware of that. We have been doing it very since. In this binary search, normal binary search questions will be there, and one topic would be binary search on answer. Binary search on answer. This is some important things. So binary search on answers are few types of questions that we generally tend to make mistakes. So we will be learning how to tackle binary search on answer questions. Before that, we will just briefly discuss what are linear search and binary search. So linear search is something like, so if this is your array 0, 1, 5, 2, 7. Let's say this is my array and its indices are 0, 1, 2, 3, 4. This is my array. And you want to search for something like target equal to 2. What you will do? You will traverse like this. Here you will encounter 2. You will return that index or something. You will just say. What is binary search? Linear search is very simple and will not go that forward. in linear search, we will be taking around order of n time. But what is binary search? Binary search is something a algorithm, searching algorithm. So firstly, for binary search, the input array should be sorted. Clear. This is very clear. The input array should be sorted. Right. So if the input array is sorted, we can apply binary search over there. If we can apply binary search over here, then let's apply how to apply. Well, we'll see. So we can apply binary search something like this. See, if my input is something like 1, 4, 5, 9, 16, 20, 25, 29, 31. Let's say this is my array. Let's also write this indices 0, 1, 2, 3, 4, 5, 6, 7, 8. So here n is equal to 9. So n is 9 and we want to apply binary search on this. So we'll see how binary search is working. So we'll have 2 pointers, low and high. We'll always we'll always calculate the mid. So mid would be 0 plus 8 by 2. 0 plus 8 by 2 is 8 by 2, that is 4. So mid is pointing over here. Mid is over here. So mid is over here. Now I will check. Let's say we are searching for target is equal to 29. We will checking is 29 present in my array or not. 29. No, it is target is 29. Is 29 and 16 equal? No. 16 is less than 29. So just apply common sense and say me, if 16 only less, then the values that are left to the 16 will always be less than 16 because that is 29, because the elements on the right are greater than left because of the sorted property. So 16 is less. 16 is less. So we will move our low to mid plus 1. So the condition is if v of mid is equal to target, then we'll return. Or if v of mid is less than target, if v of mid is less than target, when we'll do low equal to mid plus 1. The other condition, if your target is greater than, if your mid is greater than target, then the right side values will obviously be greater than the target. So in that case, you will do else high equal to mid minus 1. These are the three conditions by which we can get our value. So let's dry run the same question. So erase this all. So let's erase this all and let's take this whole thing. Let's copy and paste this over here. I don't know why there is no option of pasting for this. One second. For some reason it is not getting, so we can dry run over here, no problem. So so low is here, high is here, mid is over here first time. So now is 16 equal to 29? No. So it is less. So we will move our 10 to mid plus 1. So now we will check 20 plus 31. Now mid would be 4 plus 5 plus 8, that is 13 by 2. 13 by 2 gives us 6. So mid is here. So is 25 equal to 29? No, it is still less. If it is still less, we will move our low equal to mid plus 1. Now low is here and here. Now 7 plus 8, 15. 15 by 2 is 7. Mid is here. Now mid is over here. Now I'll check. V of mid 29 is equal to 29. So return 7th index. At 7th index, your 29 is there. So this is how simply we can understand how binary search works. Now let's write the code for binary search. So this is the array int I equal to 0 and sorry, not I, it would be low equal to 0, I equal to n minus 1 and we'll iterate until low is less than high. We can also put low is less than or equal to high because many cases will require that. Mid equal to low plus high minus low by 2. I think you guys know why do we do high minus low by 2, just to overcome that integer overflow. So we'll check if v of mid is equal to target, then see out mid enter and return 0 over here. Else if v of mid is greater than target, your middle value is only greater than the target, then you will do high equal to mid minus 1. Else we'll do low equal to mid plus 1. That's all. After the whole while loop also, if we don't encounter anything, we'll return a minus 1, that there is no element. So let's take the same example. It was how many sized array? 9 sized array. 9 sized array with elements 1 4, with elements 1 4 5 9 16 20 25 29 and 31, and we have not taken the target as input, right? And target same target, and our target was 29. So we need to get 7 as output. Let's see. Perfectly we are getting 7 as output, and let's say target as 33, which does not exist. So here we should get minus 1 as our output. Minus 1. It is perfectly fine. Now we will discuss the applications of binary search by solving 1 to 2 or 2 to 3 questions based on the requirement. We'll solve binary search on answer to understand how binary search actually works. So let's move forward to the next questions. So let's solve 2 questions on binary search to understand how binary search actually works rather than plain binary search. Now the question is very simple. Search insert position. So we need to search the insert position. So what is, we have been given an array. Okay, we have been given a sorted array where we can apply binary search. So we have been given a target value as 5. For this the output is 2. So Phi, we need to find the insert position. We will be given a target. We need to check where the target should be inserted in the given array. So very easy. We can apply the binary search. If the element already exists, we'll return that element index. If it does not exist, if this is the case, then where we should just insert that. So it is very simple. Just apply the classic binary search over here. Let's say this is my array 1 3 5 6. Write down its indices 0 1 2 3. So this is low, this is high. Now your mid will be 0 plus 3 by 2, that is 1. Mid is over here. Now we'll check, is your mid is v of mid, that is v of mid is equal to target? No, it is less than target. So you will do low equal to mid plus 1, classic binary search, and remove this. Now you will do mid again, 2 plus 3 5, 5 by 2 is 2 again. So here is your mid. Is your mid equal to target? Yes. So return the index. So for this case, it was plain classical binary search. So if not, if the given target does not exist in the given space, what happens? Let's analyze. 1 3 5 6 and the target is 2 over here, right? So classical binary search again will apply. Low, high. 0 1 2 3. 0 plus 3 by 2 1. So this is mid. Now you will check, is your mid what is mid? V of mid is 3. 3 is greater than 2. If 3 is greater than 2, I will do high equal to mid minus 1. So high is equal to mid minus 1. So now low and mid are at the same point. Low and mid are on the same point, and you will now do mid will also come here, because 0 plus 0, 0 by 2 again gives you 0. So mid, low and high are pointing at 0th index. Now you will check, is your v of mid equal to target? No, 1 is not equal to target. 1 is not equal to 2. So it is less than 2. So you will move low to mid plus 1. Now this is a boundary condition, right? Now low is greater than high. So we will break out. But we did not get the insert position, right? No, you are wrong. The point at which low is currently, that is your insert position, because 1 and 3 between 2 lies. So 1 is that index, that is lowest index is that index where target should be inserted. So this is how we'll solve this question. Let's write the code for. So we'll always return the lowest pointer for the search space, so that is insert position. So we can always do something like so this is all nothing. We'll never return -1 because we'll always have an insert position, because it lies always inside. So in target also we have taken, so we need to modify this obviously. And here int low equal to 0 already declared, so we'll apply the binary search. Low less than or equal to high, int mid equal to low plus high minus low by 2. Now here we'll check, if your v of mid is equal to target, then we'll see out this mid, that this is my insert position with an end line, and return is 0 from here. Else if I am doing return 0 only when t is equal to 1, please make sure that if there are several more test cases, then never do return 0. Always use a bool flag boolean, or else it will completely shut down the execution of the program. Else if here we'll do what we are checking, if v of mid is less than your target, then I will do low equal to mid plus 1. Else the other case is high equal to mid minus 1. Now at last you can always print the low. This is your search, that is insert position. Now let's see for the first case. First case was 1 3 5 6, the elements were 4 1 3 5 6, and the target was 5. For this, the output should be second index. We are getting 2. Now the target is 2. It should be inserted in the first place. We need to get 1. Perfectly, it is working. So let's move forward to the next question. So the next question is find peak element. This is one interesting question. So what is peak element is the element which is greater than its previous element. So it is, let's say this is nth element, so it should be greater than the n minus 1, and it should be also greater than n plus 1. So we need to find that element. That is the problem statement. So if we construct the graph for this, so this is 1. So let's say this is 1, okay, this is 1, point number 1. So 2 would be over something more up, so 2 would be over here. This is 2. Again we encountered 1. This is 1 again. We have 3. So let's say this is 3, and we have 5 from here. We have 5 from here. Then we have 6 from here, and we have 4. So from this graph, I can clearly say that 6 is that element which is greater than 5 and also greater than 4. So we need to return 6 as our answer. So one thing you might encounter is, firstly, this sorted space is only not sorted. How can we apply binary search? So these questions are something where we apply binary search on answer. So on the search space, we apply the binary search. Irrespective of the sortedness, we can apply binary search sometimes when we encounter this many situations. So the condition would be very simple, like if v of mid is greater than v of mid minus 1, and v of mid is also greater than v of mid plus 1, then you will return mid. But one thing is very sure, that your first element and last element can never be your peak elements. Why? Because there is no left and there is no right. So we'll start our binaries first from first pointer and the last pointer. Low would be here and high would be here. Okay. What we'll do here is, when your v of mid is only greater than v of mid minus 1, so it is a peak stage, so we will move the low to mid plus 1. Let me repeat. So case is, if your v of mid is greater than v of mid minus 1, so it is some, what we'll say, it is peak stage. So we don't want to lose that peak stage, so we'll do low equal to mid plus 1, or the else case would be high equal to mid minus 1. So let's simply write this code and understand how we are applying binary search on answer on non-sorted search space. So this is all correct. This is all correct. We need to just remove this logic. So we'll obviously get a target value. Here we don't get any target value. Why do we get? We need to find the peak element, right? So this is all not required, and this line is also not required. Yep. And we should also remove this. Done. Now we need to apply the binary search. While low is less than or equal to high, and mid equal to low plus high minus low by 2. Another thing, we will start from n minus 2 and low equal to 1, because I said you 0 and n minus 1 can never be your part of our search space, because they are never part of the peak elements. And there would be another thing, like if your n is 1, then the peak element would be peak element would be 0, because there is no other thing. Cout 0 and L and return 0. This is one important case, and that's all. Okay, now I'll just check if my v of mid is greater than v of mid minus 1, and then v of mid is greater than v of mid plus 1. So this is that peak index. So return, not return, here we'll print the mid, Cout mid, end line, and return a 0 directly from here. else if, very important condition, binary search on onset. Here, if my v of mid is greater than v of mid minus 1, it is on the peak stage. Now I want my low should be incremented, or the other case would be high equal to mid minus 1. If I don't get here, so there is no peak element, we'll just simply do minus 1. So the number of elements were 7, and the elements are 1 2 1 3 5 6 4. Let's run. For this, the answer should be index number 5. Index number 5 is that 6 element where we are getting the answer. So it is working perfectly fine. And if I say this is as 5, so now there is no peak element. It should return a minus 1. It is giving a minus 1. So if I do a 6, it will give perfectly correct 7, and let's say 10 over here. Now also there is no peak element over here. It should also return a minus 1. So it is also returning minus 1. So perfectly we have solved the question. Find peak element in an array. So this is about binary search. You can also practice few other questions on lead code or anything for better understanding of this. So let's move forward to the next concept. We'll see sorting and things. So the next question is saying something like, we need to find the kth largest element in an array nums and integer k. That is, return the kth largest element in the array, not that kth largest element in the sorted order, not the distinct. Can you solve without sorting? First, let's understand what is that. Let's take the test case and understand what it is saying. So I can definitely do something like, let's paste over here and go into our screen. 1 second. Let me just take you into my screen. So it was here. So here we have been given a nums array of size 0, 1, 2, 3, 4, 5, 6 sized array. Okay. And k is 2. What does this k represent is, we need to find the kth largest. For now, k is 2. We need to find the second largest element. What is the first largest? First largest is 6. What is the second largest? 5. So we will return 5. Understood? Now, k equal to 4. We need to find the fourth largest. What is the fourth largest? Fourth largest would be something, the largest is 6, then the 5, and again 5 is largest, then the fourth largest would be 4. Understood? Here we are also considering the duplicates. How 4 got, we have understood. Now in this array, what would be my third largest? Third largest would be again 5. Now it is very clear. How can we do? Approach 1 is just by sorting. How can we sort? Let's take, it was 3, 2, 1, 5 and 6, 4. So initially sort this. If we sort this, it would be looking something like 1, 2, 3, 4, 5, 6. This is something we'll get after sorting, and it will take around order of n log n. It will take order of n log n to sort. Now I can just return the nums of n minus k. Here our answer was 5, right? Let's consider. And k was 2. Now 0, 1, 2, 3, 4, 5. These are my indices, 0, 1, 2, 3, 4, 5. Now let's understand, my n is 6 and k is 2. What is n minus k? That is 4. We are returning nums of 4. What is nums of 4? Nums of 4 is nothing but 5. We are returning 5. Is our answer right? Yes. So with this approach, we are getting order of n log n time complexity. It is very easy. Like, first sort the array and return the n minus kth index. This will give in n log n approach. But he has clearly mentioned that, can you solve it without sorting? So we need to understand how can we solve this question without sorting. So here we can use the concept of heaps. What are heaps? Let me just clear what is heap. So heap is a data structure. It is priority queue. Heap is a data structure where it stores data based on priority. Like, there are two types of heaps. One is max heap, one is min heap. Okay, two types. So what is a max and min heap is? Min heap, I will just explain min heap. Max heap is just the reverse of it. So let's consider the things like 5, 3, 2, 1, 4. So what does, if this is my array, If we enter these elements in my min heap, how does the min heap looks is, min heap will always store the minimum element in the heap at the top of it. So if I consider this as my min heap, okay, and it is the top equal to something. So now firstly 5 3, let me not just give the commas and just write 5 3 2 1 4. Let's say these are my arrays and I want to put these values into my min heap. It would be something like, first 5 is occurring, I will put it in my array. So now there is no element in my min heap, so it is the minimum element, so it is on the top. Now we have encountered with 3. Now what happens is, there would be a rearrangement. Now it will check is, what is the smallest element between 3 and 5. It is clearly 3, so 3 would be my top and 5 would come inside. Now 3 is the minimum element between 3 and 5. It will always give us the minimum element. Now 2 is coming. If 2 is coming, it will check. It will not compare again 2, 5 and 3. It will only compare the incoming element and the top element. Between 2 and 3, 2 is small. So 3 would be rearranged and 2 would be on the top. Okay. Now we are coming with a 1. Now it will check, is 1 small or 2 small. Definitely 1 is small. So we'll take 2 inside. Now 4 is coming. Now it will check, is 1 small or 4 small. 1 is only small. So we are left with 1 at the top. By this we can easily say what is the minimum element in my array. So it was 1. By seeing also we can say it was 1. So this is how the rearrangement and reshuffling in a min heap occurs. So every rearrangement takes around log n time complexity. The every rearrangement, that is popping or adding inside my heap, takes log n. So what happens if I pop? If I tend to pop elements from my min heap, what happens? If I pop something from my heap, it will always pop from the top element. So let's consider, if it was my heap, right, 2 3 2 5 3 and the top was 1, right? If the heap name is pq, if I do pq dot pop, if I perform a pop operation, that is a deletion operation, the 1 would be gone. 1 is popped. Now from all these, the smallest element would go up. This is how the pop operation just gets in the min heap. Why the min heap is used for finding the kth largest element? Let's understand. Let's take a example which they have given. So it was something like 3 2. Let's try to copy. Let's see if it gets copied. No, it is not getting copied. Let's write manually. It was something like 3 2 1 5 6 4. It was something like 3 2. It was 3 2 1 5 6 4, right? It was 3 2 1 5 6 4. Now let's take a min heap. Let's take a min heap, and before saying, let's write the approach to. Let me explain the approach. The approach was something like, push every element into the heap. When the heap size is greater than the k, that is, if the heap size exceeds the k, then perform pop operation. Once the array gets exhausted, you will have the kth largest element in the top. This is the approach. Very simple. Let's understand. Let's perform the min heap actions. So for now, what was the k value given to us? The k value was 2, right? The k was 2. So we want the second highest and the answer was 5, right? Let's see, does our approach work or not here. So let's just dry run our case. It was something like, firstly we'll keep 3 and there is no element, so 3 is at the top. Now 2 is coming. It will just check, is 2 small or 3 small? Definitely 2 is small, so 2 will be rearranged. Now 1 is coming. If 1 is coming, now you just check. I have pushed 1. Now my size of the min heap. What is the size of the min heap now? Size of the min heap is 3. My size of the min heap is 3. It is greater than 2. Now what should I do? Before doing something, it will rearrange, right? It will rearrange. 1 is at the min and 2 is. Now my size is 3, but my k value is 2. The condition where pq dot size, that is size of the heap, is greater than k, I will do pq dot pop, that is I will perform a pop operation. If I perform a pop operation, I already said that it will pop from the top. Now 1 is gone. If 1 is gone, now my top is 2 and now 5 is entered. Between 5 and 2, we already know 2 is only greater. So now you observe, again my size is 3. Now size is 3 and it is greater than 2. If it is greater than 2, I need to perform a pop operation. So 2 is also vanished. Now for now my new top is 3. Now I will include 6. Now 6, 5 and 3. Now 6, 5 and 3. Now my size is greater than 3, greater than 2, that is greater than k. Now size is 3. So again I will perform a pop operation. Now my new top would be 5 and 4 is pushed into my stack, the heap. Now it will perform a reshuffling because 4 is smaller than 5. So 4 would be up and 5 would be, 5 would be down. Now it will check 4, 5, 6. The size is 3, but my k was 2. I will perform a pop operation. Now again the top would be 5. Now my array got exhausted. There is no array element and at the top we have 5. That is what our answer. This is how we can easily solve. Let's write the code file. I hope it is very clear after dry running the case. Now it is a very, I can say you can write the code in your language very easily. Let me write in C++. So it was, firstly we want this size. It would be something like nums.size and we need to define a min heap. In C++ we define such as priority underscore queue of int comma vector int comma greater int. This is how you define a min heap in C++. So what was the first thing? We will push all the elements in our min heap. So I can just write for int I equal to 0, I less than n, I plus plus. I'll do just pq dot push of nums of I. After pushing, I will check if my size of heap, if it is exceeding my k, then I will do a pop operation. Just that. After everything, it will by default do every insertion and pop operation. After my array get exhausted, that is whole elements got chance into getting into the min heap, at the top I would be having my kth largest element. I can just return the top of the element. So if I just run this, I hope it should work. It got accepted and let's submit also. Yeah, it got submitted. It is the very best approach where we are, for the worst case, we would be doing, at majority we would be doing k number of removals. That is the time complexity would be around k log n, which is far better than n log n. N is the size of the array, but here only k, where in this question k would be very less than n. So this is how we can easily solve the kth largest element, and it is one of the very important question. In the similar types of question, I guess there is also, you can see top frequent elements is also same, and third maximum number you can easily do. There is also, I guess, one thing called kth smallest element or kth largest element we have solved. You can do kth smallest. Kth smallest is just the reverse of this. You can use the max heap for doing. You can also solve using a min heap, but max heap will give you the optimal answer. Now let's move forward to the next question. Now the next question is saying that a majority element. What is a majority element? Majority element, given an array nums of size n, return the majority element. What is a majority element? The majority element is the element that appears more than n by 2 times. You may assume that the majority element exists in the array, always exist. Okay, let's understand what is the test case saying. It is 3, 2, 3, right? Let me write it very clearly so that you can understand. 1 second. It was nums is 3, 2, 3. So let's understand what is he saying. So here my size of the array is 3. An element in an array which is repeating more than n by 2 times, then such number is called as majority element, and he is clearly given that a majority element will always exist in the array. So there is no case that what if there is no element which is repeating more than n by 2 times, not repeating more than n by 2 times. So here we can see the frequency of 3 is 2 and 2 is 1. So 3 is that element which is repeating more than n by 2. What is n by 2? 3 by 2 is 1. What is the one element that is repeating more than one time? That is the number 3, right? So we will return 3. You can clearly see the output is 3. Now let's also see the the test case number 2, where you can clearly see the size of the array is 3 and 4, that is 7. 7 by 2 is 3. We need to return an element which appears more than 3 times in the array. More than 3 times, which element appears? Here 2 and here 2. The frequency of 2 is 4. So we will return 2. For this, we want the frequencies. To know the frequencies, we can easily use the hash map, right? So if I take 2, 2, 1, 1, 1, 2, 2. This was our test case. So 2, 2, 1, 1, 1, 2, 2. I can declare a hash map of what type? Of integer, obviously. My key would be integer and also my frequency will also be integer. Firstly, I am at here. Now my key is 2 and frequency is 1. Now my key is again 2. Now the frequency count increased to 1. Now my key is 1. Now its frequency is 1. Now again we encountered here frequency 2. Here frequency 3. Here frequency 3. Here frequency 4. Now 2's frequency is 4, 1's frequency is 3. And the size of the array was 7, right? 7 was the n value. N equal to 7. So n by 2 would be something like 7 by 2, which is nothing but 3. We want the element whose frequency is greater than 3. That is there any element greater than 3? Yes, it is 4. What is its key? We need to return its key. It is 2. We can simply use maps to just overcome this question. So let's write the code for this. It is very simple question. So firstly, we want the size. We can definitely do int n equal to nums dot size. Now we want an map of int comma int, where the first int is the key and the second int is the frequency. That is the key and its corresponding value. Let's name it as mp. Now let's put our values for auto it in nums. For auto it in nums, I can definitely do mp of it plus plus. Now my frequency table has been created by this statement. Now I will just check. I will check in my in my mp, that is it in mp. What is mp representing? The first value is the key, the second value is the frequency. If my it dot second, what is this it dot second? It dot second is the frequency. If my frequency is greater than n by 2, then what should I return? I will definitely return it dot first. What is this it dot first? It dot first is the key. That's what I am returning. It dot first. It dot first is the key. That is the value. At last we can return -1. There is no case because he always said that there will be a majority element for sure. So if I just run this, it will work as perfect as it is. So accepted. Let's submit the code. And hash maps are something which are very commonly used in every question in this. There is also an alternative way how to solve this question, that is using the Moore's voting algorithm, but there is a no constraint. You can definitely use maps by taking extra space. There is no harm at all. You can definitely do. The Moore's voting algorithm is slightly confusing. You can skip this part for now. You can definitely use hash maps. I just took this question because I just wanted to explain how we can use the hash maps and how hash maps are important for problem solving. Next, let's solve one interesting question. This is something like a very commonly seen pattern in these types of question, where we need to print some patterns. So we are been given an matrix that is a 2D grid, and we need to print it in a spiral form. Let me copy and paste it over here. Let me try to give the glimpse how the pattern actually there. We need to print this in a spiral format. What is this spiral fashion? Spiral fashion is something like we are at the top left corner. We'll start from here. This is 0 0, right? We'll start from here. The pattern would be something like we'll go right, then we'll go down, then we'll go left, here, here. If it was something like, it would be something like this. Wait a second. It would be something like a spiral. It would be something like this. We need to print like go right, then down, then left, up, right, down, left, up, right, down. A pattern like something. Here it is completely based on the logic how you write. So here what are the four states that are once is going right, going down, going left, and going top. One thing is very clear. If we go right, what is constant? This is the row. The column differs, but we are in the same row. That is the first row. If we are going down, the column remains state. That is we are in the third column, but the row differs here. Right. Now, if we go left, the row remains same, the column differs here. If we go up, the column remains same, but the row differs. You can clearly see if we are going left and right, the column is getting varied, and if you are going up and down, the row is getting different. One thing is being constant here, so we can definitely use that. Here we will be using a 4-pointer approach. Now let's understand how to just code this. I would be taking this as my main row. Okay, main row and main column. This is my main row, that is the first row is my minimum row, and the first column is my minimum column, and the max row is the last column. That is the max row is the max column, and the max column would be the last column. So I would be playing with these boundaries and just printing. So let's understand by coding this. See, firstly we need to return the vector that in an integer array we need to return the order. So if we just see, the printing would be something like 1 2 3. We'll go right first, then we'll come up to down how much we can come, then we'll go left, then we'll go up, then we'll go right. We can't go up because one was already visited. So this is how we can solve this question, and let's try to understand and write the code for this. Firstly, we want the sizes, that is int n equal to matrix dot size. Okay, this will give my rows. Int m equal to matrix of 0 dot size. This will give my columns. Okay, we want a vector of int answer to return our answer. Firstly, we want 4 variables. I said I want min row equal to 0 because we are at the 0 row is my minimum row. 0 column is also my minimum column, right? Minimum column is also 0. What would be my max row? Can someone say? Max row would be something like, if my 0 is my minimum row and minimum column, it is something like m minus 1 would be my max column. Here it is a 3 by 3 cross grid, but array indexing starts from 0 0, so it would be something like 2 comma 2, right? So 2 is the maximum row and 2 is the maximum column, so it would be something like m minus 1 and n minus 1. So the maximum row is n minus 1 and maximum column is m minus 1. Now what would be my boundary condition? It is, I will loop on going things while my minimum row is less than maximum row, and also my minimum column is less than equal to maximum column. Then I will do certain amount of things. Firstly, what was our agenda? We will go right. How can we go right? You just observe. If we go right, we are in the minimum row. The row number is not changing, but the column is changing from, it is minimum column and we are going up to maximum column, right? The row is same, but columns is changing from minimum column to the maximum column. So I can definitely use a loop here. I can do, for going right, for representing column I am using j. I can do from j will vary from the minimum column and it will go up to maximum column, right? And I will do a j plus plus, and I will push back, that is I will add in my answer like, that is matrix of, what is my row number, what is my row number in this. The row number would be, the first row is nothing but the minimum row, right? I'll just write the minimum row is constant, and what is varying, the column is varying, so I'll write the j. This will give the go right. After going right, what are we doing? After going right, we went down. If we went down, the minimum row gets incremented, right? Because we are jumping from the first row to the second row. Firstly my minimum row was this, but I came here. So if I came now here, the minimum row is my second row. I will just do a minimum row plus plus. And a very important check you need to write is, if my minimum row is greater than maximum row, or my minimum column is greater than maximum column, I will break out from the row. This is one statement which will do. Now after going right, now we will go down. For going down, let's see, for going down, now we have printed up to here. Now we need to go down. If we go down, what is constant? We are at the maximum column. The column is constant because the maximum column is constant. We are going from minimum row to the maximum row. So we can loop here. It is simple. We can just do, for now I will use I because I am representing my rows. I equal to minimum row, I less than or equal to maximum row, and I plus plus. Now I will answer dot pushback of matrix of I, and j would be maximum column because maximum column is constant. Now we have come down. If we go left, what is varying? We will do maximum column minus minus. Why did we do maximum column minus minus? Because we have printed up to here. Now we want to go left. This was previously maximum column, but now maximum column will come here. We will do maximum column minus minus, so we will go up to 8. So maximum column minus minus we have done. Again we need to write same statement like this, because if we go beyond the boundary, we will just break out from the this loop. Now we have went right down. Now we need to go left. To go left, what is varying? We are going from the maximum column to the minimum column. I hope it is very clear now. You can just write the other thing. We are going from the maximum column and j greater than or equal to the minimum column, j minus minus, and we will push back. What will push? We will push back. What is constant in this? We are in the maximum row. So I is constant. So we will put maximum row and a matrix of maximum row and j. This will print the left. If we went left and now we are going up. If we go up, the maximum row gets decremented, right? Now we will do maximum row minus minus and print the same statement, because if we violate the condition, we will just break out from the loop. Now right is done, down is done, left is done, just the up logic is left. To write the up logic, what can we do? To write the up logic, we are currently up here and went here. We want to go up. If we want to go up, we will go from the maximum. We will go from the, it is maximum row. We will go from the maximum row to the minimum row. We will go from the maximum row to minimum row. Now what is this? This is minimum column. This is constant. This is how we can easily go up. We can write the logic like now it is go up. We can write for int j equal to now I, because we are working on rows, we are going from max row to I greater than or equal to min row and I minus minus and answer dot push back of matrix of I comma what is common constant, that is minimum column. Minimum column is constant. Now we have done minimum row plus plus, maximum column plus plus, maximum row plus plus. Only minimum column plus plus is left, right? We did not did the minimum column plus plus, that is what is left. So by this, and also lastly we need to write this. By this I guess our answer got filled, and let's return the answer. Let's see if we are getting the correct answer or not. There is some compilation error. There is no semicolon. Let's give a semicolon. Let's see. There is another okay, I did not write int. It would be int. Okay. Anything else? I don't think so. Yeah, it got accepted, and let's submit the code. So this is how we can solve it. It was one interesting question where it required a deep logical thinking for this, where we written a good piece of code for this. Now let's move forward to the next question. Now the next question is a very famous question where it is a combination of we can solve, I will say, two approaches, but the first approach might not work because when the input is very large we cannot just rely on that approach. So let's understand what are anagrams. Anagrams are something where two strings are said to be anagrams, where the frequencies in the both the strings gets matched. That is nothing but an anagram. So let's consider we need to write a boolean logic function where if the both strings are anagrams or not, we need to just check. Let's understand by the test case. Here we have been given with anagram and nagaram. Now you check A matched, N matched, A against a G R A M. Everything got matched, so these two are true. You can even do A repeated twice, N repeated once, G repeated once, R repeated once, M is once. Even in Nagaram is also same. If the frequencies of both the strings are same, then they are said to be anagrams. If you see RAT and CAR, for RAT, R is once, A is once, T is also once. For CAR, C is once, A is once, R is once. AR matched. Where is T? Here no T, here no C. So RAT and CAR are not anagrams. First approach is using sorting. You can use sort. What happens if you sort? If you sort, see, car and rat, right? If you sort them, let's take a true case firstly. So if you take let's say what would be one good, let's take anagram and nagaram only. I'm not able to see any. If you consider anagram and nagaram, if you sort them, they will be same number. See, anagram and nagaram. If you sort them, first A would repeat, then the smallest number digit is G, then you will have M R. That's what 1 2 3 1 2 3 4 5 6. Yes. If you even sort nagaram, first A's would become, that is A, then G, then M, R. If you compare these both are same. By sorting you can easily compare both. If both are same, they both are true. They are anagrams. But let's say rat and car same. If you just sort them, it would be something A, R, T, M, N, O, P, Q, R, S, yes. A appears first, R appears first, then A, C, R. Are these both true? No. Are these both same? No. So here we will say false, they both are not anagrams. Now here, when something like frequencies all come, we'll use hash maps. Why this approach doesn't work? Because we'll use an complexity of n log n. When n values are very high, like 10 power 6 or 10 power 7 or 10 power 8, when 10 power 8 you will definitely get a time limit exceeded error. But 10 power 6 would work because it would be something, log 10 power 6 is nothing but 6. So 6 into 10 power 6 works, but 10 power 8 you will definitely get an TLE. So how to overcome this? Will use the frequency tables. So let's actually understand how. We'll see. It was nagaram and anagram. Let's draw the frequency tables for both. The key would be character and the value would be integer. Here also it would be something like character and integer. The key would be character and integer for both the hash maps. So let's consider this as my mp1, map1, map2. Okay. Now my first element is m. So my first element is n. I will push n and its value is 1. Now I am here. I encounter a and its value is 1. Now g. Encounter g, value 1. Now a, increment a. Now r, introduce r, 1. A, 3. M, introduce m and 1. Now for this, a, 1. N, 1. A, sorry, it would be a, 2. G, 1. R, 1. A, 3. M, 1. Now let's compare mp1 and mp2. Both are same. Now in this case we'll do true. But let's see for char and rat. For this it would be something like C1, A1, R1. Now we'll check. R1, A1, T1. Are these both same? No. So we will return false. Here we are using additional space. Space is order of 2 into n because we are using 2 hash maps. Time complexity is but order of n only. We have decreased from order of n log n to order of n. This is how we can easily solve the question. Let's write the code for valid anagrams. Let's first write the sort logic also. Sort s dot begin comma s dot end. This will sort my string s, and sort t dot begin comma t dot end. And now if I can just return s is equal to true. If both are equal, it will return true and they are anagrams. If both are not true, it will return false. It will work as it is a easy mark problem, but it is not the actual approach. So now let's actually write using maps. We want 2 hash maps, right? We can write map of, one would be of character of integer mp1 and map of character comma integer of mp2. You can use unordered maps also, doesn't matter. Now here we'll put our values. For int I equal to 0, I less than s dot size I plus plus, and mp of s of I plus plus. Now for int I equal to 0, I less than t dot size I plus plus, it was mp1, and here we will do mp2 of s of I plus plus. Now I have successfully put my values. Now I will iterate over my mp1 int. Now my character is my character char ch1, that is character 1 is nothing but it dot first. It dot first will give my first character, and int its corresponding frequency would be it dot second. We already know that. Now I will just check if mp2 dot find. I will check if mp2 dot find of ch1 is not equal to mp2 dot end. What is this mean? It will check if it is there or not. If it is there, it will enter into the if block. I will check is my character 1, that is the character present in the string s, is it is present in my character that is the t string or not. If it is there, now I will just calculate int frequency 2 would be nothing but mp2 of my ch1. Now I can easily check if frequency 1, if frequency 1 is not equal to frequency 2, then what it is? I will just return false, because both the, if it is present in string s but it is not present in string t, then we will return false. And also if my character is only not present in my string t, then also we will return false. Here also we will return false. When we exhausted our searching in the both maps, we did not encounter any false. At last we will return true. This is the logic for this. Let's run the code and let's see if we have made any mistake or it is working. So we are getting a wrong answer because rat and car output is true, we are getting false. Let's analyze where did we do something wrong. So if frequency 1 is not equal to frequency 2, then we will definitely return false. Yes. And mp2 dot find of ch1 is not equal to mp2 dot end. Yes, it is true. Now let me just check. One second. So the mistake which we have done is, here we need to do t of I plus plus. Even also here also we are just putting the values of s. That is why we are getting wrong answer. Now it would work definitely right. Now it has run. Now let's submit. Even here we are getting a wrong answer because 51 54. There is s equal to a, output is getting true but expected is false. S is a and t is ab. Let's analyze what is happening. One second. S is a, let's take a new page only. S is a and t is ab. Okay, let me draw the frequency table. Let me, you guys also see. It would be my mp1 and it would be my mp2, right? It is mp2 and in s I have only a and it is 1, and here it is a1 b1. The output should be false, but we are getting true, right? Output is true, but yes, we need to get what we are doing. Let me check. We are iterating over mp1. Okay, if we are iterating, okay, yes, one interesting thing is if both sizes are also not same. Did you guys understand why are we getting any why are we getting error over here? Because we are searching in mp1. Okay, mp1 has only one character and we are only comparing with a, there is no b only, so we have not encountering this. So for this, if the sizes of the both strings are different, then also they are not anagrams. Let me give an example. See, let's see ABC and ABCD. Are these both anagrams? No, they can never be anagrams. If both lengths are different, how can be anagrams? Because if the lengths are only not same, their frequencies will definitely vary. So we can keep a check like something. We can keep if my s dot length is not equal to t dot length, then we'll return false. I hope it should work now. Let's submit the code. We are getting some okay. No, one second. It is something. If s dot length is not equal to t dot length, then we'll return false straight away here. Let's see. Let's see if it is working or not. So it got accepted here. Let's submit the code. No, it got accepted. It was a minute test case, but we handled it very properly. So this is how we can easily solve the question valid anagram. Let's go to the next question. It is a very interesting question and it is a recursion question. I just took this question to give a brief logic on how to solve recursive questions. So you are climbing a staircase. It takes n steps to reach the top. Each time you can either jump or climb one or two steps. In how many distinct ways can you climb the top? I guess you did not understand the question. So let me explain. So for n equal to 2, the output is 2 and n equal to 3, the output is 3. Let's analyze how. So n equal to 2 represents how many staircases are there. That is, if we consider this is step number 1 and this is step number 2. I am a person who wants to reach from, let me just minimize this, not such a big character. Let's draw something small. Okay, I want to go from here to here. How many ways I can go? I can take a single step and again a single step. I can reach the top, or else I can directly take 2 steps to reach the top. We have given that clearly that the boy or girl can just take 1 or 2 jumps. There is no phenomena such as if there are 3 steps. So this is step number 2, step number 3, step number 3. And if he can go one step, one step, one step. This is path number 1. Or he can go one step and take 2 steps, path number 2. Or he can take 2 steps and 1 step, path number 3. But there is no phenomenon directly taking 3 steps. Taking 3 steps is not given in the constraint. So he can only take 1 step or 2 steps. So let's compute for n equal to 2 and n equal to 3. So for n equal to 3. For n equal to 2, the answer would be something like this would be 1 way, 1 plus 1. So we can reach 1 plus 1, or we can reach directly 2. So here this is one way, this is one way. Total ways are 2. Now let's understand for n equal to 3. Here we can go 1, 1, 1. So one way would be taking 1 plus 1 plus 1. Or the other way would be going 1 and 2. It is 1 plus 2. Or else the other way would be taking 2 plus 1. So these are the one way, one way, one way. Total 3 ways. This is how we can analyze how. Now for n equal to 4 also let's write. 1, 2, 3, 4. I want to go, let's take our boy. So for n equal to 4, what can we do? We can go 1, 1, 1, 1. This would be one way. Or we can take 1, 2, 1, or 1, 1, 2, or directly 2, 1, 1, or 2, 2. These are the different ways. For n equal to 4, we are getting 6 ways. So how to actually solve this? This is a classical problem of recursion. We'll solve for one case and the other sub problem will be solved. So if you can see here, for n equal to 4, the boy actually has 2 options now. He can actually take 1 jump or 2 jump. Let's break this problem. Okay, let's break this problem. If this fellow took a single jump, so I would be something like 1, 2, 3, 4. Then he would be here. If he had taken a double jump, then he would be something over 1, 2, 3, 4. 1, 2, 3, 4. If he has taken a double jump, let's draw again. If he had taken a double jump, then he would be here. Now for him, the question again breaks into the same path. Now he can take a single jump or 2 jumps. Now also he can take single jump or 2 jump. Now if he had taken a single jump, he would be 1, 2, 3, 4. If he had taken a single jump, he would be somewhere here. If he has taken a double jump, 1, 2, 3, 4. If he had taken a double jump, he would be here. Okay. If he has taken a single jump, 1, 2, 3, 4. Single jump, he would be here. Double jump, he would be over here. This is how we solve this question. It is nothing but calling n minus 1 and n minus 2. We are breaking the problem. We only know if my n is equal to 1, then my answer is 1, or n is equal to 2, my answer is 2. The other cases, the answer is something nothing but calling the same function n minus 1 and n minus 2. This is how we can easily solve this question. It is actually a DP problem, but we are not optimizing it until DP, because if you even write a 2 power n solution, let's try to write 2 power n solution. If it does not get accepted, we'll also discuss how to write DP in this. Firstly, we want we'll call helper of I am writing int n, and let's write int helper of int n. Now I can do in the climb states function also, but I don't generally write in the same. I firstly, the base case is if n is 1, my answer would be 1. If n is 2, my answer would be 2, because I can easily compute. These are the base cases. Okay, or else I will just return helper of n minus 1. This will give my one step answers, and helper of n minus 2, this will give my two step answers. If I just run this, it will easily get I need to write return. I'll write return. If I'll do this, it will definitely get accepted. Let's submit the code. Whether, let's see, I guess it's a easy mark problem, it should get accepted. It's taking time. Okay, it's getting time limit accepted, so we need to apply DP. So I'll just apply DP. For the people who know how to apply DP, you can just follow, or else it is not that important. In the Accenture, they will not ask you to just apply DP, because writing up to here is only very much great for Accenture, because they don't ask such great level of questions. I'm just solving this for your case to just understand how recursion actually works. So I'm just optimizing it by solving using DP. DP is nothing. I will just explain for the people who just don't know what is happening over here. See, when it is a solution which we written before was a 2 power n, because sub problems are just calling. I've just minimized the sub problems by storing the results in a DP array. This is nothing but DP. I have written the bottom up bottom up approach, where I'm memorizing the results. So let's see if it is getting with a very good beats. It is very simple. The approach which we have written in recursion is very much pretty well optimized also, 2 power n for Accenture exam. Sometime when we discuss DP, we'll just take up this question. For now, I think I have discussed and explained every type of variety of questions that you might get in your coding assessment. Now let's move forward to the next section, and understand how other questions are getting framed. For now, let's meet in the next section. Thank you. Let's move forward to the next question. Now, moving forward to the next question, merge sorted arrays. Why always we are taking sorted? Because sorted things like binary search, sorting spaces, everything are very favorite to the service based of questions. So merge sorted array. What is the problem statement saying? You are given two integer array nums1 and nums2. So we have been given a two arrays nums1 and nums2 sorted in non-descending order. What is non-descending order? It is nothing but ascending order. And two integers m and m representing the number of elements, that is the sizes of both the arrays respectively. Merge nums1 and nums2 into single array in non-descending order. The final sorted okay. So it is a very easy question. So this is one of the array, this is other array. Here we need to merge these two arrays such that the whole array is sorted. Let me just say, let's consider, let's leave the zeros for now. The zeros are not part of the array. We actually need to place these elements over here. So this is my array. So it is the first array, and this is the second array. For now, ignore the zeros. How we will handle the zeros is another thing. Now let's just understand 1 2 3 and 2 5 6. If these two are my arrays, then can I merge them? It is very easy, because see, the first array is sorted, the second array is also sorted. What I will do is I will create a new array of 6 size, that is size is 6. So it will be something 1 2 3 4 5 6. Why 6 size? See, the size of the first array is 3 and the second array is also 3. So the resultant array, when we combine both, the array size would be 6, right? So we would be writing 3 plus 3, that is 6. What I will be doing, I will be placing one pointer over here and one pointer over here. I will just compare which one is small. Definitely 1 is small, so I will write 1. Then I will increment 2 and 2, which is 1 no matter what, so I will write 2. Okay, not here but here, 2 comes. Then I moves here 3, right? 3 and 2 is really small, so 2 comes here. Then 3 and 5, which is small? 3 is small, so this array is completed. Now the only 2 elements are remaining, that is 5 and 6. You can just definitely write this is the sorted array, right? Now isn't it the sorted array? This is how we can simply do merging of 2 sorted arrays. This is how we do it. Is also a 2-pointer approach, but the problem over here is there are extra zeros. For this we can definitely take one temporary array and do the same thing. Like we'll just consider up to here, we'll consider up to here, we'll make an array and we'll place that. You'll just understand, just wait and watch. So it would be like firstly we want one I pointer, right? I would be pointing at, let's say we will be starting from let's say from back, I minus 1, m minus 1 and j equal to n minus 1. So I am placed at I would be no okay we would be I here, n here, right? So we can definitely do something like we can not like this, but we can see nums1 is 1 2 3 0 0 0. This is 2 5 6, right? For this we definitely want one temporary array, as I said. So it would be of m plus n size, right? M plus n size. Now here we want int I equal to firstly before that return temp. I just want to see the size of m. Is it 3 or 6? See out m. This is for just for debugging thing. Okay, this is a void function, sorry. We need to place it in the same array. It is 3, right? That is what I was thinking. So the size of nums1 is 3 but not 6. Here as we see, we are seeing as 6 elements, but when I printed, okay, it was there already m. I did not see that. So m is 3, right? So we can do let's say int I equal to m minus 1. It would be pointing at second index, and j equal to n minus 1, and my k would be something like m plus n minus 1. This would be my location. Now see, temporary array is of size 6 because 3 plus 3 6, and k equal to m plus n. What is m plus n? M plus n is 3 plus 3 6, 6 minus 1 5. That is the last index at the temp. That is there is the total size of temp is 6. So but when the size is 6, the last index is 5, right? We are standing at k. So what we can do here is, it is very simple. I can do while I greater than or equal to 0 and then j greater than or equal to 0, because this is the boundary condition, we can't go beyond this. I will just check if my nums1 of I is greater than or equal to nums2 of j. Then what I can do? Then definitely I can do something like temp of k minus minus. I will store nums1 of I minus minus. I hope it is very clear, because when my first element is greater than the second element, then I will put it at the last, because we want in the descending order. Else what we can do, temp of k minus minus would be nums2 of j minus minus, right? But if we do, will it work? No, because when the size of m or n, here the sizes are same, so it would be working fine. But when the sizes are not equal, then for that we can definitely write another thing, right? When I exhausted or j exhausted, here we can write nums for I, it was nums1 of I, nums1 not, here we can write temp of k minus minus equal to nums1 of I minus minus. And similarly for j greater than or equal to 0, temp of k minus minus would be nums2 of j minus minus. This will fill my temporary array. For now, should I show you my temporary array? It would be something like this. I think we can't print like this the whole array. Yes, we can't print it. So for auto it in temp, cout it. For your understanding, I'm just printing it how my temporary would look now. Once temporary is figured out for you, the rest question is C. My input was 12300 MC. Not my temporary is sorted, right? 1 2 2 3 5 6. Did we achieve this? Right? So what is this output? We need to make changes in the nums1, right? So it is very easy now. See, we have made our temporary, which is in the sorted form. Now you can just iterate in your temporary. It would be temp dot size I plus plus. You can definitely do nums1 of I would be temp of I. This will rearrange our temporary, that is nums1. Now if I run, it would definitely pass. I hope it is very clear. I even logged our temporary arrays. See, even this is also with 100% efficiency. So let's move forward to the next question. Now the next question is, don't get frightened or something, afraid from seeing like, does Deloitte ask 3 questions? No, it won't, but it is one good type of question that majorly everyone asks. It is not basically on trees and all. It is a tree question, but we will be not solving it in a tree manner. We will be solving it in an array manner. Okay, so we need to validate binary search tree. So we will be given a tree, and our aim is to check that if the given tree is a binary search tree or not. First, let me explain what is a binary search tree. So first, let me explain with tree. Tree is a non-linear data structure. Okay, so array is a linear data structure. What is the difference between linear and non-linear? Linear data structure is a data structure which stores data in a structured format, that is sequential or something contiguous manner. But non-linear data structure is a data structure where the elements are non-structural, non-contiguous. So tree is one of them. So in this tree, the first thing is called the root element, and this is the left, this is the right. This is okay. For the people who know trees and can understand, listen well further. No problem if you don't understand. So the process which I say here, the type of function we do here with recursion, that is very important. Let's just understand. So we need to check whether the tree is binary search tree or not. One important property of binary search tree is, when you do the in order traversal of a binary search tree, the traversal output is in a sorted format. It is a property of binary search tree. So let me come again. If you do a in order traversal, what is in order traversal? In order traversal is, first it will traverse the left, then the root element, then the right element. The in order traversal for this would be, I said left, root, right. So it would be 1, 2, 3. Okay, here the tree is very small, so we are easily seeing. What about a bigger tree? So here the in order traversal would be left, root, right. I said right. Left, root, right is the in order traversal for this. If you do an in order traversal for this, the in order would be 1, 5, 3, 4, 6. Is the 1, 5, 3, 4, 6 in a sorted order? No, right? So here we are returning a false. Here the order is 1, 2, 3. So we will be returning a true. Before that, we have understood what is in order traversal. But what is a binary search tree? Binary search tree is, there would be a root the elements to the left of root will always be smaller than the root element, and the elements to the right of root will always be greater than the root element. This is about the property of binary search tree. Okay, this is a property of binary search tree, and the important property is when you do a in order traversal of a binary search tree, the output is sorted. Now let's understand. Here we'll use a helper function, helper. Okay, this will give our answer, and we'll pass our root. For now, let's declare one in order. Okay, let's not name this as helper. Let's write get in order of bst. Okay, get in this function will give me the in order traversal of bst, not return bro, will get. Okay, will get in order bst, in order of bst. Let's write the void function, void get get in order, get in order of bst of tree node star root. If my root is equal to null, then I will return, right? And now it was left root right, so I will go left get, I will call the same function. Left is nothing but in order of, get in order of bst, and here how do we go left? It would be root arrow left. This will call my left function. Here we need to append our things. It would be something like in order dot pushback, that is appending your answer root ka value, value, that is value is data, right? Now we will call the same function get in order, get in order of bst, get in order of bst, and here we will call our right, that is left root right. This will fill my in order. Now we have the in order. Now if I just print see, for auto it in my in order array, and if I print my it, you can see for the test case number 1, we need to return, right? Let's return false for now. Let's return false. Okay, so our output for this 213, it was returning 123. We are returning false, but expected is true, right? Okay, for the second thing, the in order for this is 15346. Is this sorted? No. So if it is not sorted, we will be returning a false. Now here we can definitely easily verify if the thing is sorted or not. Let's traverse. For int I equal to 1, I less than in order dot size, in order dot size I plus plus. If my in order of I, if my second element is less than the first element, I minus 1, then it is not sorted, right? Return false. Over this we will return true. I hope it is very clear. This is the logic. Okay, now let's run and submit our code. We are getting a wrong answer. Let's see, std out 222. Are we printing something? Okay, we are just printing, right? Let's submit now. Okay, so there is also duplicate elements. How to solve for duplicates element is, so if it is also equal, then also we will be returning false. I thought there are no duplicates in this. A binary search tree typically don't have duplicates, so I just assume that there are no duplicates. Once we do an equals case also, we will be sorted. Even this question got solved in 100 meters per second efficiency, which is the best efficiency. So now moving forward to the last question, and very important and very interesting question. This question is pure logical, and this is a dynamic programming question and very important for product companies. Okay, so we'll be solving this, and TCS and all are also in a race of asking these types of questions. And let's rename this SNT. Who will write text 1, text 2? Don't do this in exam. Follow the convention. Here I am doing. So The question is longest common subsequence. So we need to find and return one integer which represents the longest common subsequence of these two strings. It is very famous question. Let's understand what is the question stating. See, here if you see, what is a subsequence in the same order but not contiguous. Substring is same order and contiguous. Subsequence, the contiguity doesn't matter until it's in the same order. So the text one is A B C D E and text 2 is A C. The common subsequence is A C E. Here also A C E. A C E are in the same order. So ACE are subsequence in the both. Here CE is also a subsequence. CE is also a subsequence. Only E is also a subsequence, but we want the maximum, right? The maximum is ACE. Here also ACE. So we need to return that. In the second one, ABC both match. So this is the longest subsequence, returning 3. Here ABC DEF. There is no subsequence. Here we are returning 0. So this is the question that we have been stated. So we need to solve this question. Okay, how do we solve? How do we solve is a big challenge for this question. So let's understand very clearly. If you can see, 15,000 people have voted this solution. That is voted this like this question. So it is very important and very famous question. So it is a pure recursive approach that we would be following. We would be starting from the last thing. Okay, we would be comparing the both text. That is, let's suppose my pointer one is at E and here it is E. So if both got matched, then one part of my sequence got matched, so I will add 1. If both doesn't got matched, I will search from here and here. This would be my approach. Let's try to understand what we are doing. Okay, first we would be requiring the length. So the length would be s dot length. It would be s dot length and let's say m as t dot length. Okay, we got the length, and here we would be returning an helper function, or let's write get LCS of strings. Let's write meaningful convention. Here this you will be writing in interviews, but not here. Okay, we will be starting with the last indices. Okay, we are sending the last indices. So let's also receive. Here we will be writing get LCS of strings. It was strings, right? First one would be string ampersand s comma string ampersand a passing by reference int i comma int j. Okay, now the first boundary condition would be if my I got exhausted or my j got exhausted, then we would definitely return as 0, because we can't go beyond left beyond that. Now first case was if characters got match. If both got matched, then we will add 1, because it is part of our answer. When characters got matched, we can definitely do something like return 1 plus same function. Let's copy this. How many times would be writing this? Copy, and would pass s comma t. See, now E and E got matched, so I would be searching CA and DCBA. So it would be ST comma I minus 1 comma J minus 1. This would be it. Now if both did not get matched, I would return maximum of, if let's say for now ABC and DEF, F and C did not match. Now I would do FED and BC का LCS and ED and CBA का LCS. इन दोनों में से the whatever gets the maximum LCS, I will return that. So it would be simply get LCS of s comma t comma I minus 1 comma j comma get LCS of strings of s comma t comma I comma j minus 1. This would be my code. If I run this, we would definitely get my answer. We are getting a wrong answer. Why are we getting a wrong answer? Let's analyze. We are getting 3 but expected is 0. Uh, let's see. Get, oh, we are not comparing and returning here. Let's That's very strange. If when character check, where is the character check? If s of I is equal to t of j, then only we will return this, right? Let's keep some indentation. So now we will be getting definitely a correct answer, because we are always doing return 1 plus so when the characters get matched, only then we will do this. So if I submit this code, we'll definitely get a time limit exceeded, I'm pretty sure. Did it get okay? Time limit. I thought we got accepted. Time limit for Deloitte NLA exam. Until here, the code is very much clean. We can definitely do this. Our NLA exam questions would not expect the candidates to solve more than this. Writing this recursive piece of code is only very much greater. People generally don't understand these things, and if you are able to pull off this solution, then there is something about you. Because writing DP is, once you write the memoized solution, writing DP is piece of cake. Now let's see. There are two things that are changing, right? Its state. So we'll require a 2D DP. The people who are not interested can skip over here, but two things are getting changed, right? That is I and j. So we will be requiring a 2D state. The thing only required in DP is the memoized code is done. So we can definitely do dp dot resize of n plus 1 comma vector of int m plus 1 comma minus 1. Now I will do just the two things. If my thing is already calculated, I will not make any further calls. I will return that. Return dp of ij. This we will do. And before returning everywhere, we'll just store our result. What we'll do? Just store our result. dp of ij is equal to this. And here also we'll store our result. By doing these minimal changes, our thing gets accepted. This is about DP. People think DP is very large, huge, very difficult. This is very easy. DP is very easy until when we are able to write the memoized code. DP is not tough, recursion is tough. Okay, things got accepted. So this was about our video. We have understood the different types of questions, patterns, everything. So I hope you the very best, and I think I was able to discuss few of the questions that are important, and this session was helpful. And if you want more type of questions, you can definitely make a comment or leave a like, which makes him motivated. It's around 12:17 at the am, that is 12:17. Still working. I would be editing this video, I would be sending. There is definitely so much of hard work. If you like this, you know the drill. You can just like or comment or do anything. You can definitely give a feedback. It would be constructive, or it would be taking you think. You can say you would be very fast, things did not understand. You can definitely comment what you feel. I hope I was able to make you understand how things like how to tackle question. When I was also stuck at one question, I came up with some solution. You can also get. So majority of these service based companies asked these story based questions. So for us, as we know the pattern, we will get two coding questions, right? We'll be having two coding questions. So in that two coding questions, we need to solve two coding questions to get prime package, and also at least one and a half for the digital packets. So today we will be discussing the story based questions. Okay, story based questions for NQT, right? So let's move forward to the next question. And previously I have already made two videos on the repetitive data structure questions based on array strings. We also discussed a few data structures like heap, maps. We discussed many other things we have discussed, and I will be planning to taking a session on bit manipulation and everything. So let's, with no further ado, let's dive into the story based questions. So let's see what is the question number one saying to us. Let's concentrate on question number one. So let's read the problem statement. The problem statement, the title is called as the smart elevator. So okay, a company has installed a smart elevator in a 10-floor building, floors numbered from 0 to 9. The elevator starts at floor 0. You are given a sequence of floor request rules. There are a set of rules, okay? So before that, let's understand, before going into the rules, so let's understand there is a company, okay? Let's say this is a company and it has few floors in it. Floors. They are numbered from 0 to 9. There are 10 floors in a company and they have installed a, let's say this is his elevator. So this up to here the problem statement is clear. Now he is building the story. Like what are the rules in it? The rules are, if the requested floor is the floor which we wanted to go. So let's say I'm in third floor and if I wanted to go at ninth floor, my requested floor will be of ninth floor and I am at currently at third floor. Done. So the rule is, if the requested floor is higher than the current floor, the elevator moves up. We already know that. And vice versa is also true, that if the requested floor, if I am at third floor and I want to go to the 0th floor, that is ground floor, then the elevator definitely goes down. These two conditions are very general and we know about them. So moving one floor, this is interesting. Moving one floor takes 2 seconds. So let me understand. I'm currently at third floor. Okay, here is 210. I'm currently at here, and if my request is going to the fifth floor, I want to go from third floor to the fifth floor. So crossing each floor takes us 2 2 seconds of time. That is, if I wanted to, if the time taken here is time 0, for fourth floor the time will be 2 seconds, and for the fifth floor going it will be taking 4 seconds, because plus 2 plus 2, that is what he is saying. So going from one floor to another floor will take 2 seconds, and stopping at a floor takes 1 second. That is, let me say, see, you are going from 3 to 4. 4 we are not stopping. It is not something like you will be also stopping at 4. See, let me explain it very clearly here. If I am at third floor and if I want to go to seventh floor, generally what happens is somebody will also be deboarding at fifth floor. That is not there in our case. So if I am there in current floor, then I will directly go to the requested floor. There are no intermediate halts. So when we stop at the requested floor, it will additionally take 1 second of time. So stopping is taking one time. So for this, the time would be something 3 to 4 takes 2 seconds and 4 to 5 also take 2 seconds. So 4 seconds, and additionally we are stopping at fifth floor, so it will take 1 second. So 4 plus 1, total 5 seconds of time we are taking to reach from third floor to the fifth floor. Done. So that is what the question statement. If the request is same as current floor, see, I'm at third floor and I want to go to third floor, you will think 0 time. We are not in. No, this is wrong, because if you press, it will stop for 1 second. So that 1 second time is also calculated over here. So the if you are at same floor and the requested floor is also same, then the time taken is 1. This is one of the important edge case. People generally miss this edge case in this question. So the motive behind taking this question is taking this edge case, that people generally think, if I am at the same floor and I want to go to the same floor, then there is no time taking thing. But he has said clearly that if the request is same as current floor, only 1 second, that is stop time. So what is our task? Our task is to calculate the total time to serve all requests in order. Very easy. So let's understand how we can solve. So this is a building, floors 0 to 9. We'll always start from the floor 0. We'll directly not go to the third floor, right? We'll always start from floor 0. So initially our total time is also equal to 0, and we are at current floor. Our current floor is also 0. So let's say I want to go to the fourth floor. It would be something taking first floor, second floor, third floor, and fourth floor. We are going four floors up. So it will take 2 seconds. So here we are taking 8 seconds, and additionally we are stopping for 1 second. So plus 1, 9. So it is not something like you will just get one request, you will get multiple requests. So we need to calculate the total time for multiple requests and return the total time, or return or print the total time. So the problem statement is very clear. We have understood what actually the question is asking us to do. So let's quickly write the code and understand what are we actually doing. So the one thing we are getting as input is the number of requests. So n represents the number of requests. So every we will take a loop and take the number of request input for every time. So I plus plus here current we are currently at current floor equal to 0. We are currently at 0th floor, and our total time currently is equal to 0 because we have not served any request. Done. So for every time we will get a request, so we will take that input as request. Done. Now the total time, how we are calculating? The total time is nothing but the current floor to the requested floor difference will give the difference between the current floor and requested floor. So if I am a third floor and if I want to go to the seventh floor, so 3 minus 7, that is minus 4. So we can handle that minus and positive by using the absolute function. So 7 minus 3 gives us 4. So reaching from third floor to seventh floor, first the difference is 4. So reaching each floor, crossing each floor takes us 2 time. So 2 into 4 gives us 8. So we can definitely do something like total time plus is equal to absolute of the requested floor minus the current floor multiply by 2. I hope it is very clear, because multiply by 2 is why we are doing is from one floor to one floor it is taking 2 seconds of time. So after that we will halt at the required floor. So if I am from third floor to seventh floor, I went to third floor to fourth floor, 4 to 5, 5 to 6, 6 to 7. When I finally reach at 7, the elevator will halt for 1 minute of time. 1 second of time. So we can do a total time plus plus. And now, is this done? No, because we need to update our current floor. So we are currently at the requested floor. This is a simple code that we are required to write, and let print the total time and take something as input. Take something as input. So if we see what is the input, so let's say 8 things are coming, 8 requests, and we are currently at 0th floor, 9, 9, 1, 5, 5, 2, 8. So let's say this is my input, and let's run and observe our output. So for current floor request, what I'm doing, current floor equal to request. So it would be current floor equal to request, right? So let's see, our answer is getting something as 68. Let us observe, are we getting 68 or not? So let me copy this, and let's go to the iPad and try run this case. Are we getting 68 or not? Is our logic correct? According to our code, we are getting 68, because maybe our logic might be wrong or code something might be wrong. Let's analyze and tally our output. If we get 68, then it is definitely correct. According to our code, it got set. So we are currently at 0th floor, and the total, let's say it as answer is 0. So from current floor, that is 0, we are going to 0. So the same floor, the difference is 0. 0 into 2 gives us 0. But do we increment something? Yes, because even if you want to go to the same floor, the lift will halt for 1 second. So we'll increase the answer by 1. Now my current floor is 0 only. Now from 0 to 9 we want to go. 0 to 9. What is the difference? That is 9. Difference is 9. 9 into 2 gives you 18. So 18 seconds is the time that you will reach from 0th floor to the 9th floor. That is 18 seconds, and additionally 1 second it will hold. So plus 1, that is 19. So it will be plus 19 will give you 20. So 20 is your current answer, and your current floor, you are currently at 9th floor. Done. Now you want to go from 9th floor to 9th floor. Difference is 0. It will only be incremented by 1. So this would be 21. Your answer is 21, and you are at currently at 9th floor only. Now from 9th floor to 1st floor, the difference is 8. 8 into 2 gives you 16, and additionally 1. So 17. 21 plus 17 gives you 38. You are with 38, and you are now in 1st floor, because 9 to 1 is calculated. From 1 to 5 you want to go. Difference is 4. 4 into 2 gives you 8. 8 plus 1, that is 9. So increment by 9. This is 47 now. So, and your current floor, you are at currently at 5th floor. Now 5 to 5. 5 to 5, the difference is 0. Difference is 0, and it will halt for 1 second. So difference is 0, so you will just add 1, so it will be 48, and you are currently at 5th floor only. Now you want to go from 5th to 2nd floor. 5th to 2nd floor, the difference is 3. 3 into 2 gives you 6. 6 plus 1 is 7. So add 7, it would be 55. 55, and you are at 2nd floor now, because 5 to 2 is done. Now you want to go from 2 to 8. 2 to 8, the difference is 6. 6 into 2 gives you 12. 12 plus 1 is 13. So add 13. 13 is 68. So according to our dry run, that logic, answer is 68. Did we get 68 in our code? So 68 is the answer. So this is how we can simply solve this question by writing a simple code of piece of code and this. So if we can see some edge case that I talked to you, if I want to go to the same floor, then here the answer should be 5, right? 5 request is, it should be giving us 5. Let's see if it is working. So answer is 5. So this is how simply we can solve, and I am very sure that you have easily understood the code, because I have also dry run and make you understand how actually things are working. So now let's move forward to the next question. So yeah, let's move forward to the next question, and this second question is something very interesting question, and expects us to implement so many things. So you might think the question is very small and it would be done very easily, but it is not the case. What is the question saying? Let's understand the question very clearly. So the problem name is the digital locker system. A school locker has a 4-digit pin. Okay. So let me demonstrate it. It would be something like, uh, I hope my screen is visible. Yep. So there is a 4-digit so pin. So this is 1 2 3 4, 4-digit pin. For a school, if you want to, there is a locker, and if you want to access it or something, you need to provide that pin. So to open the pin, so like there is a algorithm or something. If you enter it in that way only, the pin gets opened, the pin gets approved, and the locker gets opened, or else it no. So the functionality is, so there is a student who tries to open the locker, and if he gives the input in this format, then the locker gets opened, or else it is locked. So our thing is to just check either the what we say, the boy is a boy or girl, the student is able to open the locker or not. So let's see what is the functionality that the user is expecting us to solve. So a student enters a number. Okay, if the number contains exactly 2 even digits, so he is entering 4 digits, and if the what we say, the pin has exactly 2, not more than 2 or not less than 2, exactly 2 even digits, then okay, the first case got passed. Then the sum of digits is divisible by 3. So if he do 1 2 3 4, what is sum of digit? 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 2, 1 is 10. So is 1 2 3 4 a valid pin? Because it is having 2 even digits. 2 and 4 are 2 even digits, but is the sum 1 plus 2 plus 3, that is 10, divisible by 3? No, it is not divisible by 3, so it is invalid. pin and it is locked, the student is not able to open. So 1 2 3 4 it cannot be the same. If you give something like it should have exactly two even digits and the sum of that should be divisible by 3 and no digit repeats, that is you can't do something like 2 2 2 2, that is 8. It has more, it is violating everything. All characters are greater than 1 and also it is not divisible by 3 and it doesn't have two even digits also. So the input should be in some format that it should satisfy all these conditions, then the pin will be unlocked or else it would not be. So we need to think of that test case and should write the code. So firstly, what the question is saying, I hope it is clear. The first condition was it will give you four digits. So the first condition you can check, if the input only provides three digits, then unlock. It will not unlock. If he gives five digits, it will not unlock. If he give 10 digits, it will not unlock. So this is the first case. And second case would be exactly two even digits. It should have exactly two even digits. Third case is sum of digits should be divisible by 3. Fourth case is no digit should repeat. If the student is that sharp enough, do you think he will write TCS NQT? No, right? So if the student is that much intelligent, he could have done something else. So the TCS people are expecting the students to solve this much. They want you to implement these many functionalities in one coding problem. So let's write the code and when we dry run things, right, we'll understand. It is not that complicated. It is very simple problem only, but they are expecting us to solve many things. So the one and only thing that we'll get as input is the digit, that is the number that is entered by the student. So it would be something like 1 2 3 4. If it is 1 2 3 4, then we will check if 1 2 3 4 is valid or not. So this is about it. Now let's check. First thing is, if the get number of digits of n, if it is not equal to 4, then just print invalid input n line. That is the exactly 4 only we are required to write. So if it is not equal to 4, we will just print invalid input and return. So we will stop the program there only. Then if another condition, we'll write this function. This is not an inbuilt function, we need to write that. If get, the second condition was get even digits. If get even digits is of n not equal to 2, then also we will provide, we'll say that it is an invalid input and return. This is one case. There are multiple things that need to be handled in that function, that we will also take set and everything. And if what we say, I guess we are good to right. If get sum of digits, it will get my sum of digits of n divided by 3. Let's divide it here. Okay, it will give me the total sum, and if we divide that by 3 and if it is not equal to 0, then we will here also will say it is invalid input and return 0 even over here, because it is an invalid input. Are we missing any case? Repeating case, right? The repetitive case, I think we can handle it. In the uppercase. So I think we can also include and get even digits and let's say and get number of digits is of n not equal to 4, then also we'll do. So I'm writing the rough code over here, or else any other case it will say valid input, valid input. Let's see, there might be some functional changes that we need to do. Let's write the code and understand if there are any functional changes. So firstly, we want the number of digits, right? It will return something. Int get number of digits of int n. In the previous video, I have already said that how do we get the number of digits. So it is very simple. Int get number of digits, we can do here. Yep. The repetitive task, we can write another function instead of doing set and everything here. We can first return just the number of digits. So int digits equal to 0, while n is greater than by 0, digits plus plus. I am not going to again repeat this here. This is already done in the last class. N by equal to 10, and last will return the digits. This will give me the number of digits. Okay. Int get sum of digits would be int n, int sum equal to 0, and while my n is greater than 0, sum plus is equal to n modulo 10, n by equal to 10, and here we'll get this sum, right? So get even digits is also something, right? Int get even digits is one function that we need to write. Let's say int even digits equal to 0 for, so why I'm writing for while n greater than 0, int reminder equal to n modulo 10. If my reminder modulo 2 is equal to 0, then if my last digit is equal to a number and it is divisible by 2, then I will do even digits plus plus. Definitely this is correct, even digits plus plus, and we'll do n by equal to 10 obviously, and return even digits. So these are few functions that we required, and is any bool get, let's, for 1 second let me comment everything. I don't think we need to write these many cases. We can do in a simple go. Bool get what we can name, same digits, right? Bool check, maybe bool check of int n. It will int get number of digits of this n, and here we'll do set of int st. Why I'm taking a set is I will insert all these values into the set, and I will compare my size of set with the number of digits. Yeah, so if the size is equal, then there is no repetitive things. So int original digits is equal to get, this will original digits will store my total number of digits that we have entered, and I will push these n values into that, and I will compare my set size and the original digit size. If both are equal, then there are no duplicates. If both are not equal, then we'll return a false. So what we can do is while n greater than 0, what we can do is int reminder equal to n modulo 10. The same function is used. I in the last class I said this function is very useful. We will use so many times this function. That is what we are doing. So we can do st dot insert of reminder, and n by equal to 2 we can do n by equal to 10. Now we'll check if my st dot size, if my set size is equal to the original digits, then return a true, else return a false. I think I have implemented the whole functionality over here. So the overall functionality of the code, that is checking whether any character is repeating or not, getting the even digits, in getting sum of digits, and also getting number of digits, the whole functionality is written. Now we just need to just check if any condition is violating. So we can just do, first let's check for the what we say, repeating things. If check of n is equal to false, or if any case fails, the input is invalid. So if check of n is false, then input is invalid. Or get number of digits, in get number of digits of n is not equal to 4, then it is also false. And or get sum of digits of n modulo 3, because we need to check the divisibility, not equal to 0. If it is not equal to 0, then also it is a wrong input, right? So even this case will handle. Or last case is get even digits, and get even digits of n. If it is also not equal to 2, strictly not equal to 2, then we'll print, here we'll print invalid input. Else here we can print valid input. Let's check for something 1 2 3 4. For this it should be invalid because sum of digits is not equal see, it is perfectly fine. So 1 2 3 4, let me go to the iPad screen. 1 2 3 4, first it will check for check function of n. So 1 2 3 4 will be passed. Here we are checking, is any repetitive is there? No, it will not return a false, it is true. So this condition is where we are. So this condition is not violated, this is correct. So next we'll check for, next we have written get number of digits, it will return a 4. So it will return a 4, right? Get number of digits, number of digits, this will return a 4. It is equal to 4 only, this is fine. Then we'll calculate the sum. 1 plus 2 plus 3 plus 4 gives us 10. 10 modulo 3, 10 modulo 3 will give us 1, which is not equal to 0. Here it is failing. So either of one false, then we'll either of one condition is true, then we will return a false, right? Because it is violating our condition. So we are giving a invalid input. Now let's go forward to a valid input. So what is valid input? Let's say 6 1 4 7. The sum is, no repeating character is there. There are exactly two even digits, and sum 11 12 plus 6. This should give a valid. Let's see. This is perfectly giving valid. Now if I do F5, it should give invalid. It is invalid. If I remove two things, only give two things, 614, it should give invalid. So our functionality is working extremely properly. So this was one of the very good question, and I would rate this a very good question because we are handling many things in this problem. So let's move forward to the next question, that is third number of question. So now let's move forward to the third question, the warehouse box arrangement. This is a greedy question. Before saying the question, we'll be already solving greedy type of questions also. So greedy is one of the algorithm, okay? It is an approach where we generally sort our space. What is greedy is, the name specifies, we always want to maximize things, maximizing profit, everything. This comes under greedy things. So okay, this question we will be solving using the greedy approach, greedy algorithm. So what is the question saying? The warehouse box arrangement. A warehouse receives n boxes, each having a weight. Okay. Manager wants to form pairs such that each pair must have equal total weight. Each box can be used only once. If impossible, print -1. So we will be given an input such as if we can form inputs, if we can form the pairs, then we need to return the number of pairs formed, or else we will just return a -1. So the input format is something like, we will get the size of the array and n separated array elements. So these are the constants. Let's not go into the constants and understand what is the root cause of the question. So there are two test cases over here. Test case number 1, test case number 2. 1 2. So here the size n is equal to 8 and the values are 1 3 2 4 2, 4, 1, 3. So what the manager wants you is, he wants to, if there are 8 elements, there will be 4 pairs, right? There will be 4 pairs, so that you can accumulate two things, two elements in a single box, and the box can only be used once, and the box sum should be same. So the approach is very simple: sort it. These type of things, every greedy question you will do it by sorting. If you sort, it would be something like 1 1 2 2 3 3 4 4. Now you just compare, if first and last sum, if we are able to accommodate it, then you will just do a answer plus plus. Then I is here, j is here. Again sum is same. Your sum will be just the minimum plus maximum. The min plus maximum will give you the sum, the initial sum. So 5, the box, every box should have 5 size. So here 1 plus 4 is giving you 5, 1 plus 4 is also giving you 5, 2 plus 3 is giving you 5, 2 plus 3 is giving 5. The array is valid. So the number of pairs that you can form is 4. What if there was an extra 4 here, over here? This is one condition where you can directly return false without sorting the array, because when your n modulo 2 is not equal to 0, why is this? Because if there are 9 elements, how can you make pairs among this? So if there are 9 elements, w1 w2 w3 w4 w5 w6 w7 w8 and w9, if there are 9 elements, okay, let's say w1 and w2 got paired, w3 and w4 got paired, w5 w6 paired, w7 w8 paired. Who will w9 pair up? He is not the single, right? So if your element size is it is not divisible by 2, if it is not a even number, then you can definitely not do that. So let's understand for this case. So it was 6 triple 1 double 2 3, 6 triple 1 double 2 3, right? Here you will sort, it is already sorted. If it is already sorted, then the sum would be 4, right? Sum is 4. So you will make these two as pair, 1 comma 3 as one pair. Then you will make 1 comma 2. Is 1 comma 2 the size is same? No, the sum is not same. So here you will return false. Even here you will say 1 comma t, here this 1 comma 2 is 3 sized, this 1 comma 2 is 3 size, but this 1 comma 3 is 4 size. But each and every box should carry the same weight, right? So this functionality only we need to do. It is very simple problem. We can just do it by sorting. So let me just we want the n size obviously, and we don't everything, we don't need all this, so we can remove this. So we want a vector as input, right? Vector of int v of n for int I equal to 0, I less than n, I plus plus, just take the input of v of I. Now we'll sort it, right? Sort v dot begin comma v dot end. Before sorting we can also check if before also, here only we can check if my n mod 2, what is n mod 2? If it is not equal to 0, then cout -1 here only and return as 0. We need not to proceed further. Then we are sorting it. Now int target would be v of 0 plus v of n minus 1. Definitely, right? The first element the first plus last would be our target. Now you will take two pointers, int I equal to 0, int j equal to n minus 1. int pairs is equal to 0 for, not for, while I is less than j, classical two pointer approach. Now you will just check if my v of I plus v of j is not equal to target, then straight away return a minus 1, cout minus 1, end L, and return a 0. Else do pairs plus plus. If it is there, then do a pairs plus plus, move your I pointer up, j pointer minus. At last you can do cout pairs. This is your answer. How simple the code was. Now let's take our input. What was it? It was 8 sized array. It was 8 sized array, and 1 3 2 4 1 3 2 4 2 4 1 3. This was our array. So for this, that pair should be 4, right? We are getting 4, and I said at last I have added 9. For this it should return a -1 because the size is only not modulo 2 is. Why are we getting? Okay, we need to change the input size also. It should be 9. It is not taking 9 as part of our input. It will give -1 now. And if we do a 10 over here, now the size modulo 10 modulo 2 is giving us 0, but it will not form any this, right? It would be -1. So I hope this question is very clear, and I don't think so I need to even explain by dry running it, because it was a classical greedy question where the input is sorted and your target would be the first minus last, because you will always maximize, because when maximized output is only not getting acclimatized, then how can you put another things? So we are doing the sorting, then calculating the target. If any target, if any pair, that is v of I plus v of j, is not equal to the target, if they are not getting summed up to target, then we are returning -1. Let's also take that this case 6 1 1 1 2 2 3. For this it should give a -1 because the target is 4, but any other things will not get, because 1 plus 3 is 4, 1 plus 2 gives you 3. So this will return a -1. I hope this question is very clear. Now let's move forward to the next question. So let's move forward to the fourth question now. The fourth question is something like the power grid failure. So what is this question actually saying? A town has n houses in a row. Each house has a power consumption value. If 3 consecutive houses have strictly increasing consumption, the grid overloads. Your task: count how many times overload happens. Input format is given. So this is one of the easiest question. Let's understand what actually the user is saying us to. So this is the input given for us. So there is 9 sized array, and the input is 2 4 6 3 5 7 1 2 3. So if 3 consecutive houses, let's say this is as my house 1, consecutive triplet 1, this would be my triplet number 2, triplet number 3, triplet number 4, so on. So we'll just do 2 4 6 3 5 7 1 2 3. Now let's say this is as my triplet number 1, and this as my triplet number 2, and this as my triplet number 3. This as my triplet number 4. This as my triplet number 5, triplet number 6, triplet number 7. We need to count which triplet, how many times is the power grid output, that is power grid consumption, is getting failured. That if you see among 2 4 6 3 5 7 1 2 3, if you see it was 2, it was 4, again it went to 6, 2 4 6, 3 consecutive hike. We want to check the hike. If is there any hike between 4 6 3? If you plot, 4 is something here, it is 6 and 3, it is not a hike. Now you check 6 3 5, 6 is here, 3 came here, and 5, it is also not a hike. So we want to see which elements, which triplets are causing that. One is for sure 2 4 6, 3 consecutive elements. You just pick a 3 triplet and check if it is causing a power consumption hike or not. 2 4 6, one of it is 2 4 6, and 3 5 7 is also one of them, and 1 2 3 is also one of them. So it is one of the very easy question. You can just do a, what we say, if condition, we can solve this. So we want a vector as input for int I equal to 0, I less than n, I plus plus. You can do c in v of I. Now you can just traverse in the array. I less than n minus 2 only I will go, because we can't do, it will be over the boundary, right? We will just check if v of I is less than v of I plus 1, and is v of I plus 1 is also less than v of I plus 2, then you can just do answer plus plus. Here you can define an answer equal to 0, and at last you can just return the answer. For that our test case we had three, right? Three three hikes, so it was 9 sized array: 2, 4, 6, 3, 5, 7, 1, 2, 3. The answer for this should be 3. A very easy code. We are getting -1. Why are we getting -1? I am not okay. This condition should be removed. I hope now it is very clear, and we will get 3 for this answer. So very easy thing. And if there is any 10 and 10, now you will get 4, because this is also one block. 2, 3, 10 is also a block where the hike is there. Very easy problem. Let's move forward to the next question. There is nothing more and interesting to describe about this question. It was very clear. Let's move forward to the next question. So let's move forward to the last question of today's discussion. So it is one of the good question, and we will be learning a new thing in this. So the problem number 5 is the message decoder. You will receive a coded message as a string. Each digit represents how many times do we need to print the next character should be printed. If no digit before character, print it once. So if you just see example, it is as 3a, 2b, 1c, right? So 3a, a should be repeated thrice, b should be repeated twice, and c should be repeated once. This is the simple sorry, this should be repeated once. So this is the input format. So we can definitely do something very easy for this. For this we are getting a string as input, right? Let's take a string as input. Extra base brace SK. So string s, same s. Now we'll traverse into the string. For I into I equal to 0, I less than s dot length, and I plus plus. Now first we'll calculate how many times is the string getting. First we need to know whether it is a digit or not. There is a inbuilt method in C++, is digit. Is digit is the inbuilt method, is digit of s of I. It will check if the given number is a digit or not, like 1, 2, 3. If it is a digit, then int count is how many times it is repeating. It would be something like s of I minus 0. If you remove that, let me explain what are we doing. So we are currently at here. So s of I is character 3. It will have some ASCII value. We are subtracting it with 0. It will give me the 3 as the input. That is, it is 48 and it would be 51. 51 minus 48 will give me 3. This is ASCII conversion. You need to know about this. So now I will just print it. Cout string of count comma s of I plus 1, the corresponding thing, and I will do a I plus plus. Else cout, if it is not a digit, just print it. Cout s of I. That's all. This would be a simple code. It was like 3a, 2b, 1c. It should be a, b, b, c. a, b, b, c. This is simple code that we have solved. So the main thing I took this question is to explain each digit function and also how to calculate the frequency. So ASCII conversions, you need to know that how to convert. There is two lowercase function, uppercase function, is digit, is lower, is upper, everything. So many functions are there. Here the string of this will do, it will print the number of occurrences of the next character. This the function will do that. So this is about today's class. I hope it was very clear, and let me know if we want to solve many other questions of this kind. So you can definitely comment for part 2, and we'll be taking that questions, and we will be solving about them. Thanks. I hope you clear and get any maybe prime or digital role. Thank you. And this video is mainly centric to the profiles that are prime and ninja. Sorry, not ninja, prime and digital. Because in what happens in ninja is mainly focused on the behavioral part. Like they test your communication skills, as ninja offers 3.6 lpa or and digital gives you 7.5 and prime gives you 9, right? So here the package is more, so they expect the students to be good at technical part. So we'll be discussing few concepts and the questions that an interviewer tends to ask in the technical round. The behavioral and the HR part is not covered in this video, so we will be learning about what are the technical questions that majorly a technical interview will happen. So firstly, what are the topics that you need to prepare for your technical interview are: firstly, searching and sorting, algorithms. Like anything between searching and sorting, in searching you will be have the binary search and along with the linear search. Everyone knows about linear search. Binary search, you need to know what actually binary search means, how the search phase we eliminate, what is the concept of low and mid pointers, high pointer, everything. And coming to the sorting algorithms, firstly, that is bubble sort, then you will have selection sort, insertion sort. These are basic, mostly everyone knows, but the interviewer will mainly ask questions from merge sort and quick sort. These two are something which even the product based companies as well as the service based companies tend to ask to a student. So we'll discuss what is merge sort and what is quick sort along with the time complexities. So time complexity and space complexity is such an area where an interviewer will be more interested, because he will ask the time complexity of any algorithm or searching algorithm or sorting algorithm. So you need to know what are the time complexity, what is best case, what is average case, what is worst case, you need to know. So now let's not waste any time and know what is quicksort and how actually quicksort works. So firstly, what is quicksort is, quicksort is a sorting algorithm. How basic it is, sorting algorithm. So I know what is sorting algorithm. We can sort an element of arrays whether in two ways, that is in ascending order or descending order. There are two ways. The logic is same, you need to just interchange few statements, it will sort in the ascending or descending order. So okay, we will arrange the data in such a way that the data is either in ascending order or either in descending order. Clear? Now quicksort and merge sort works on the principle of divide and conquer. What is this divide and conquer? We divide the search space and conquer, that is we merge and divide, that is dividing the search or the element of arrays into two equal parts or some parts and applying operations on it. It is purely recursive based approach where we will follow. Now let's understand how actually quick sort works. I am pretty sure that once you understand how quick sort and merge sort, because I teach this in very not in a normal way, you will easily understand how actually quick sort and merge sort works internally. So it is very simple. Quick sort, first thing is select pivot. Okay, select pivot. What is a pivot? Pivot is something where actually the change happens. Pivot is something, the place where abnormal behavior starts. So you can choose pivot as your starting element or middle element or last element or any element in your array. So for now, for our convenience, I will choose the first element as my pivot. So firstly, let's say this is as my starting index and this is as my ending index. So let's write ending index. So 0 is my starting index and 5 is my ending index. It is a 6-sized array. I need to sort. If I sort my array, it will look something like this. Okay, 9, 14, 19, 24, 27, 29 in ascending order. Now let's sort in ascending order. Descending is also very simple. So I am saying that let's assume my first element is my pivot. Okay, let's say so the algorithm is very simple. Quicksort says that if you choose this pivot, place the pivot. I will write the algorithm. Okay, choose pivot. Okay, the first step is choose pivot. You can choose any element, choose pivot. Now second point is place pivot in the correct place. What does this mean? So if you actually see the sorted part, my pivot is 24, right? 24 is my pivot element. In the sorted part, where does the pivot rise? In the third index, right? So 24 should lie somewhere around 14. So you need to get this index. Now the task is how to get this index and how to place this 24 over here and 14 over here. We'll just swap. So the third step would be something like get the pivot index. Now once you get this pivot index 3, now just swap. Okay, up to here it is very simple. Now once you have swapped 24 and 14, now let's say for now I will just use blue, and let's say 24 got here, and somehow we got the 24 where actually 24 lies. We have swapped also. Now it is very simple. Now the elements to the left of pivot should be less than pivot, and the elements on the right to the pivot should be greater than pivot. This is the simple logic behind quicksort. Let me repeat. Firstly, you will choose one pivot location. You will place that location to its correct location by doing something. We'll discuss how do we do that. We'll place that. Now after placing the pivot at its correct location, now to the left of pivot everything will be lesser elements, and to the right of pivot everything would be greater. Now when you will stop this iteration, whenever you will just exhaust the like when you will get the position, like when your starting index is greater than ending index, you will stop everything. Now let's dry run so that we will understand what actually we have done. So let me erase this for a second and copy few of the things, because let's not waste our time. So now let me just copy this my array. Let's copy and paste it over here. Okay, we have got our array. Now it is very simple. How do we do? So I said that for now let's write this is as our starting index, this is our ending index, and my pivot is pointing over the first location. It is very clear. I have taken pivot as my first location. You can take any place. So how do we get this 3 as the correct index? Because 24 should lie at the third index. So it is very simple. You can just keep a counter variable or any variable and initialize it to 0. Now just loop. Now take an j variable. Okay, j is at starting index plus 1. J is at 9. So now you will just iterate. You will just say that, let me just rub this, and let's say I am at here. Okay, now you will just compare. If my pivot is greater than, if my pivot element is 24. If my 24 is greater than the element, I will increment my count. So is 24 greater than 9? Yes. So just increment my count. My count is here. Now I came here. Is my 24 greater than 29? No. Go. Is my 24 greater than 14? Yes, it is. So increment your count. You got 2. Now front. Is my 24 greater than 19? Yes, it is. Increment and go here. Is my 24 greater than 27? No, it is. Now we have exhausted our search space. Now we are left with the element count 3. So we have got the index 3. This is how we get the index of the pivot. So we have successfully got element 3, that is index 3. For now my index is 3, right? I have got my pivot index. Let's write it as pivot index. I am writing with pi. For now my pi is 3. We have choose the pivot. We have placed the pivot in the correct space. This is something. This is the second step. So we have got the pivot index. It is 3 for now. We need to swap. The last step is swap. So if we swap the pivot element 0 and 3, it would be something like 24 would go and 14 will come here. 14 will come here and 24 will come here. Let me write 14 with the correct with the black ink only, because there is a reason. See, now 24 is that element in my array where the search it is in the correct place. So let's write something like, let's do placed. This is the correct position of 24. Now I said that once you place the pivot in its correct position, your task should be, you need to place the elements that are left in the left place. You need to place the elements that are less than the pivot. and in the right side you need to place the elements that are greater than pivot. So it is very simple. Now you take two pointers. Let take it is as I, it is j. Place I at si, j at ei. Now you will just compare. If the element on the I, if the ith element is less than the pivot, you just increment. So 14 is less than 24, increment. Is 9 is less than 24? Yes, increment. Is 29 less than 24? No. We have got something. Let's wait. Now at the j pointer, is 27 greater than 24? Yes, decrement. Is 19 greater than 24? No. So here I and j are violating. Now just swap these both. If you swap, you would be left over with something like 14, 9 and 2 and 4 are swapped. 2 and 4 are swapped, then you will get 19 over here and 29 over here and 27 over here and 24 is sorted. Now you can just verify. You can just verify this is my pivot. Everything are in the left are less than the pivot and everything in the right are greater than pivot. You can just say, but my array is not sorted. You can say this part is less than pivot and this part is greater than pivot. The main core logic is completed. Now you will just, what you will do is, you will call the same quicksort function. The same quicksort function from the array, the starting index and pivot index -1. It will do the same steps. Now the same steps will be performed. I will choose 14 as my pivot. This would be my starting index, ending index. I will place 14 here, 9 here. Everything would be same. And I will call quicksort of, for this part I will call quicksort of ARR, comma, my starting index for this would be, if this is my pivot index, it would be pivot index +1. So I will call pivot index +1, comma, ending index. This is how simply we can sort an array using quicksort algorithm. I hope it is very clear. Now how quicksort works. You can easily explain the interviewer how actually quicksort gets internally worked. So now let's understand quicksort. Quicksort time complexity is something around, for best and average case it takes of n log n, and for the worst case it takes n square. This for worst case and this is for best case, right? This is the philosophy and the background of everything about quicksort. Now let's discuss something very easier than quicksort. It is very easy algorithm, that is the merge sort. How actually merge sort works. So it is also same. Merge sort is also working on the divide and conquer algorithm, where we will divide the array space and do few of the operations and the array will be sorted. So here there are two cases. If the size of the array can be odd length array or even length array. If the size of the array is odd length array, divide the array into n by 2 size and n by 2 plus 1 size. So for example, if my array size is 7, so you can't do like 3.5 comma 3.5, right? You can't just divide the array in 3.5 parts and 3.5 parts. So what you will do is, you will just, let me just say, so one part would be of 3 parts and another would be of 4 parts. So this would be 3 parts and 4 parts, 2 equal parts. So this is n by 2 parts and this is n by 2 plus 1 parts. This is how you divide the array. For something like odd even size array, you will just equally divide 4 and 4. This is how we divide the array space in merge sort. Compared to quicksort, merge sort is very easy algorithm. Let's discuss how merge sort actually works. So what happens in merge sort is, now let's write the indices and check what is the size of the array. So if you just see, it is 0, 1, 2, 3, 4, 5, 6, 7. So 7 plus 1, it is 8 sized array. If it is an 8 sized array, it is an even length set. We can divide the array in 2 equal parts, that is 4 parts and 4 parts. Let's actually do that. So if you divide the array into 4 parts and 4 parts, it would be something 0, 1, 2, 3. And it would be something like 4, 5, 6, 7, right? So it would be 12, 31, 25 and 8, it would be 32, 17, 40 and 44. Do this dividing until the size of array is 1. So you will divide it again. It is 4 size, so you will divide 2, 2. So it would be something like 12 and 31, and it would be something like 25 and 8. It is also 4 size, so divided 2, 2. It would be something 32 and 17. It would be something like 40 and 42. Now if you divide it, it would be 1, 1. Again 1, 1, 1, 1 size there is 1, 1. Now here it would be something 12, it would be 31, it would be 25, it would be 8, it would be 32 and it would be 17, it would be 40 and it would be 42. Now it is very simple how we have exhausted the part. Now it will do some rearrangement, that is we'll use 2 pointers. So out of 12 and 31, you need to place them in ascending order. So out of 12 and 31, which is small? 12 is small, so 12 will be placed and 31 will be placed. It is already sorted. Internally happens everything. 12 and 31 will be rewritten again. You will not understand in this case. Now let's move to the next case where 25 and 18, right? So out of 25 and 18, what happens is rearrangement happens. So 25 and 8, which is small? 8 is small. So there will be a reshuffling. Here 8 comes here and 25 goes here. I will just explain for these two cases. This you can easily solve. The right side you can easily solve. So what happens here is, let me just write. Now if you see these two, what internally happens is, here the size is 2, here the size is 2. So 2 plus 2, that is 4 sized array will be created. 1, 2, 3, 4. So here it was 12, first block was 12 and 31 and second block was 8 and 25. Here we will use the 2 pointer approach. You can take 2 pointers, I pointer and j pointer, place it at the beginning. You will compare, is 12 small or 8 small? Definitely 8 is small, so increment here and place over 8 here. So we'll write 8 here. Now we'll compare, is 12 small as 25 small? Definitely 12 is small, so we'll increment I and place 12 here. Now you will compare, is 25 small or 31 small? You will definitely say 25 is small, so 25 will be placed. 25, if 25 is placed, we are exhausted and the rest element 31 is placed. Now the reshuffling over here would be sorted, right? Here you will send this sorted space, that is this space. Let me just copy this, and the same thing will appear over here, right? This is how the internal sorting begins. Now 8, 12, 25, this is sorted. Now this is sorted, right? The same things happen here. Out of 32 and 17, it would be something like 17 and 32, and it is 40 and 42 are sorted. Now it would be something like, the sorted space would be, out of 2 pointer approach, 17, 32, 40 and 42. It is already in sorted fashion, so it would be 17, 32, 40 and 42. Now again I will put I pointer here, j pointer here. Now this space would be sorted something like, let me just erase this, how actually it works. So it is very simple. You can just write, let's say I and j, 8 is small or 17 is small? 8 is small, so 8 would be placed and I is moved front. 12 is small or 17 is small? 12 is small, so 12 is placed, I is went ahead. So 25 and 17, 25 is small, I will 17 is small, I will place 17. Now 25 and 32, 25 is small, 25 I will place and move ahead. Out of 31 and 32, 31 is small, I is exhausted. Now only these are present, so 30, j is here. Now I will place 40, j moved ahead, 42. This is how we sort the array using merge sort. Now it is very clear, we have understood how quick sort works and how actually merge sort also works. Now these both are divide and conquer based approaches. Both time complexity is n log n. But the major question where interviewer asks is the time complexity of merge sort, even in the worst case, is also O of n log n. Of n log n. Why? So why? You can you can say that we can always prefer merge sort. No, you can't actually use merge sort, because in quick sort you will not use any space except the recursive stack space. But in merge sort you will always make temporary arrays, where we were creating the temporary arrays here, here, here. So you will always create the temporary arrays in merge sort. So the space complexity would be something of n, which is guaranteed in merge sort, but there is no guaranteed space we are taking in quick sort. So both have their own limitations. Here in the worst case, when the array is in the descending order, that is the worst case, where in the worst case it takes of n square, but it will merge sort will always guarantee of n log n, but it will take additional space. This is about merge and quick sort. The first question came straight away from the lead code, which was add binary. This was the first question that was asked in today's exam, and the second question was also very easier than the first question. So as we can see the pattern, the first question is slightly medium based and the second question was very easy, very basic question. So let's not further waste any time and discuss our first question. Okay, so what is this question stating is add binary. So we have been given in two binary strings a and b, written their sum as binary string. So we will be given two binary strings of same length. Okay, the length of the strings would be same. We need to perform the addition operation on them and return the new string of new addition done string we need to return. So for example, if we discuss, let's say my a string is suppose, let's take something darker, right? Let's take this. Okay, so if my a string is 1010 and b string is 0011, so this would be my input. I would be given string a and string b. Okay, so we need to perform the addition operation on these strings, and whatever might be the result, we need to return it as a string. This is the question. So for this we need to know the binary addition. So binary addition says that 0 plus 0 gives us 0, 0 plus 1 gives us 1, 1 plus 0 gives us 1, and 1 plus 1 gives us 2 in decimal, but in binary format 1 plus 1 gives us 0 with a carry of 1. That would be 1 0. 1 0 represent 2, right, in the binary format. So this is what. So if we do the addition here, 0 plus 1 would be 1, 1 plus 1 would be 0 with a carry of 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. So this would be our answer. So if we check, it was 8 4 2 1, right? This is 8 plus 2. 8 plus 2 gives us 10, and this is 2 and 1. This is 2 plus 1 gives us 3. It is 13. Are we getting 13 over here? 8 4 2 1. 8 plus 4 plus 1 gives us 13, right? So the answer got matched. This is a simple approach. For this we can just do a carry, and we will just iterate from the the right side from the ending, and we will perform. See, this is very straightforward, very easy question. So for this, firstly we want string answer, where we will store our answer and return that. So firstly we want the indices, right? We will follow the two pointer approach. I would be a dot length, a dot length minus 1. We would be pointing at the last index, and j would be b dot length minus 1. Now these are my pointers. Now I will just do, while my I is greater than or equal to 0, or j is greater than or equal to 0, I will perform my operations. Before that we also want the carry, right? We'll hold some carry. For starting, the carry would be 0, and we'll calculate this sum, and we will also perform until my carry is also greater than 0. We can write carry greater than 0 or only carry. Only carry is also a greater than 0 value only. So firstly we will calculate the sum. Sum will be always the carry initially. Okay. Now when we will compute the sum, if my I is greater than or equal to 0, only then we can get the index, right? Or else we can't get the index. So it would be something like sum plus equal to what? A of I minus 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 the character 0. Why did I do this? See, if we see, a of I will give us a character, right? Suppose we are initially at here, so 0, it is a character. When we get an character from a string, it will be as a ASCII character. We are subtracting it with 0. So it would be around 0 minus 0 will give us 0. The ASCII value of it would be 48. 48 minus 48 will give us 0. If it was 1, so we would be doing 1 minus 0. It would be ASCII subtraction, and it would be 49 minus 48. Here we'll get 1. I hope you understood why we are doing minus 0. So we are doing minus 0 in this basis. So, and here we will do b of j minus minus character 0, and we'll check if my j is greater than or equal to 0. Okay, now at last we need to append, right? Answer dot push back. What we need to add? We need to add just sum modulo 2. Sum modulo 2 plus the thing which we subtracted will add over here. Now this, after this we'll update our carry. The carry would be carry equal to sum by 2. Now if we can see that once the whole iteration is done, we traverse in the reverse direction. So my answer would be, for this, if we compute over here, our answer was 11101, right? It was 1101, but we traversed it from here. My answer would be 1011. So we need to reverse this part. If we reverse this part, it would be 1101. We can use the inbuilt reverse function for reversing that. So we would do reverse answer dot begin comma answer dot end and return our answer. This would be the simple code for the question. So it got accepted. Let's submit and see if my logic is correct. We solved it in 100% efficiency. This is a simple code. If I just explain you again, we made two pointer approach, maintaining a carry. So initially our sum would be carry, because for every time the sum will be differ, right? 0 plus 0 would be 0. So we will calculate the sum every time. We will only take the character if it is in the range. So we are checking a boundary condition range, and we are adding sum modulo 2. Why sum modulo 2? Because we are dealing in binary. So we are doing sum modulo 2 plus the character. Here we will get a value. If we add plus 48, it will be turned into a character. We are doing that. Lastly, we are updating the carry. Then we are doing the reverse, and we are returning the answer. If we submit, it is working with 100% efficiency. So this question, many people got struggled because it was not that straightforward question. People did not know binary addition or something, so they failed to actually do this thing. So this was somewhat tricky question, but the next question which we will be solving is very straightforward question. So this was the second question that was asked, and it was very basic, very basic. So if we see, the second question is saying that Damon, a student of class 12 at Dream International School, Bangalore. He has appeared for final examinations in 5 subjects: mathematics, biology, English, Hindi, and social studies. Each subject is scored out of 100 marks. Determine whether Damon is eligible for JEE, medical, both, or fail based on the following rules. JEE eligibility is mathematics should be greater than or equal to 90, biology should also be greater than or equal to 90. This is what JEE exam I don't know, because what is the correspondence of biology. Overall percentage should be also greater than 80%. So for medical eligibility, your biology marks should be 90, greater than 90, and overall percentage should be greater than 60. If both conditions are satisfied, print JEE and medical. If marks in any subjects are below 30, or if no eligibility criteria are met, print fail. This is about the question. Percentage, this is how we follow the percentage. So the things over here is, first thing is we have given 5 subjects, and there is Damon. We need to check his JEE or medical or both or fail. This is the thing that we need to see. So if we see JEE, for JEE eligibility criteria was he should get mathematics greater than 90 marks, biology 70 greater than 70 marks, overall marks should be, percentage should be greater than 80. For biology, these are few of the conditions. So we can simply use if else conditions, right? We can do if and else and simply check for this. Let's write the code for this. Firstly, Let's take one CPP compiler. Let's go into this, and let's take C++ only. Okay, hash include less than bits /std c++.h using namespace std int main function return 0. Basic boilerplate is done. So we need to take 5 subjects as input, right? For now we can write int a, b, c, d and e. So we are taking 5 things as input, that is b, c, d, e. We have to take an input. First thing we can do that, we will check for the fail condition. If any marks are less than 0, then we will print fail, right? So let's write if a is less than or equal to, or it's just strictly below 30. So a is less than 30, or b is less than 30, or c is less than 30, c is less than 30, or d is less than 30, or e is less than 30. Then we can simply print fail and print a new line, and we can definitely do something like return 0 because he has failed in one of the subject. Now after this we can definitely see, let's pull this over here, and we can check here mathematics is greater for eligibility of JE. He need to be greater than 90. For that we also need the percentage, right? So we can write float percentage would be simply total marks a plus b plus c plus d plus e. This will give my total marks divided by the total marks would be 100, 100, 100, 500, right? 500. This would be 500 and into 100. This would be giving us the percentage, right? We have got our percentage. Now for bool JEE, for JEE criteria was if his marks should be greater than 90, biology marks should be greater than 70, and overall percentage should be greater than 80, right? For now, okay, so let's take A as mathematics, B as biology, right? Because we are making comparisons out of that. So the condition was the mathematics marks. Let's say A was mathematics. So A is, if my marks of mathematics are greater than or equal to 90, this is one condition, or sorry, and it should be right, and biology marks, biology is let's represent as 70, and the overall percentage should be greater than how much? It should be greater than 60%. Then he is qualified for JE. Then we'll write bool medical would be bool medical biology marks should be greater than or equal to 90, and overall percentage biology marks is greater than or equal to 90, and then the overall percentage should be greater than 60, right? It was 60. Okay, first one was 80, right? For JE 80 marks, 80%, and here it is 60%. Now the very simple, if we qualified both JE and medical, both are true. If both are true, then we can write cout qualified both JEE and medical, and we can return over from here. Else if only JE, cout qualified for JEE, and we can return 0 from here. Or else if only medical, then you can write qualified for medical and print a new line and print and do a return 0. Or else we'll just print not qualified and failed, and we can, if we don't do return 0 also, this is the simple program that is been asked. So here they tested your basic knowledge, Let's, if we see there is no test case, but you can definitely give, see, let's run this and give some input. Okay, let's say my mathematics marks are 91 and biology marks are 85, and let's say I got 20 marks and 65 marks and 45 marks. For this my answer should be fail, right? There is some compile error. What did we do? Did we miss anything? Okay, we have missed the semicolons over here. If we run this, the answer should be failed, right? Because we got less than 30 marks in one of the subject. What happened? Why it is not getting? Yeah, we are getting fail. So if you have completed the video until the last part, there are very high probability chances that you have covered every topic and questions. So generally TCS don't ask DP and graph problems and also a few other advanced questions. But if we want the same type of questions, we will be solving DP, graph, recursion based questions. So we can definitely comment for part 2 or something. So I will make questions on DP, graphs and also recursive questions. So I hope this lecture was very helpful, and I hope you you guys get sorry, you guys get selected in any good prime or digital. And if you want any more types of questions, you can definitely comment for next part or something. We'll make it very sure. Thank you. Have a good day. Bye bye.